Good morning, everybody. Welcome to... We don't have slides behind us. Turn the slides behind. They'll be coming in a second. Welcome to Global Azure London. It's lovely to see you all here, and thank you for coming out. Obviously, this is our second edition that we're hosting. We hosted last year as well, but yeah, it's great to see you all in a new venue as well. You've found the way to the new Microsoft Reactor space, which is cool. Okay, so we're going to get started in a short moment. Thank you for your patience whilst we sorted out fire alarms, technical issues, and whatever else was going on here today. I just want to say a couple of important things before we do get started. Number one is that we want this to be a safe and friendly space for everybody involved. So we have a code of conduct that we ask that you abide by. There is a link behind me, of course. No, but it's globalazure.net/COC, and you can see it there. For people on the stream, I hope that's on the screen now for you too. I'd love to know, people watching online, where you're dialed in from, because I know already in the chat we have some people from India. We have Henk saying hi from the Netherlands, which is awesome to see, but yeah, let us know where you're dialed in from. Global Azure is a series of events happening across the world over this 3-day period. Yesterday night, I think today and tomorrow too. So there's going to be plenty of content, not least the 11 fantastic speakers we have here today. So hopefully you can engage with some of that outside of the event. Social media, the hashtag Global Azure is the way to connect and share your experience of the day. Please do. The people who will be presenting today really want to hear your feedback and want to hear you celebrating all the great stuff that they present. We're going to kick off with a talk from Nick and Josh in a second. Sorry, Jake in a second. Sorry, and we will. We'll have plenty of fantastic talks crossing like AI topics, Azure, 2 storage talks, which I'm really excited about because they look particularly interesting. We've got a nice keynote from Amy Boyd from Microsoft towards the end of the day as well. So I expect it to be lunch will be 12:30, and we have a couple of talks that will be going on as well during lunch. There's never really a moment where there won't be some fantastic
Sorry, just a quick one on the toilets, please. So toilets are straight through the store. You can see ladies are on the first right and the gents are on the second right. And fire exits as well on the same.
Fantastic.
Don't use the lifts, please.
Hopefully we won't be needing fire exits today. Yeah, as Rav said, toilets outside, coffee, tea in the corner for those that are here in person. I'm Callum, this is Purnima. It's a wave people on stream can't see, but we're sort of hosting today, responsible for the event. Let us know. With that, I'm going to pass over to our first duo of speakers, which is Nick and Jake.
Good.
Thank you. Give a round of applause.
Can you guys see online?
Yeah.
Cool. Can everyone hear you?
Showing okay on.
We need mic? Do we need mic? Cool.
The ceiling.
Okay, cool.
Right.
Welcome.
Good morning. Yeah, I'll let you.
Okay.
Nick, you go.
So, welcome to our talk on our session in Global Azure. My name is Nicholas Chang and I'm with Jake Welch. We're doing a session on Azure AI Terraform Exploring Options. So who we are first. So like I mentioned, my name is Nicholas. I work for a company, Microsoft partner called Kanos. And I'm currently a senior platform engineer and I'm very active in the community. So I have a blog. I'm recently an MVP as well in Azure, and I've got a user group, so Azure Community MTS. And goes to Jake.
Yeah, hi everyone. Jake Walsh. I'm a senior solution architect for CDW UK. Also lucky enough to be an MVP as well. Work predominantly in the Azure space. Do lots of Terraform. Plenty of people in this room that I've probably bought about Terraform before, but it's something I'm quite passionate about. Yeah, lovely to meet you all. Thanks for coming in today. Quick overview of our agenda. I'll start by saying I am a top-level mumbler, so if you can't hear me, please shout at me. Also, if you have questions, please call them out. Let's keep it interactive. There's no such thing as a silly question, so happy to field questions. We're going to cover a brief overview of the Azure AI services. Pretty hot topic at the moment. We'll talk about Azure Terraform, a very brief overview. That could probably be the subject of a much longer session, but just kind of give a bit of an overview of that, a bit of an example. Talk about how you might use that.
We'll run through like a demo on how you can deploy Terraform with like some of the private endpoint things as well, and we'll end it with like high level architecture and how you can integrate with your landing zone reference. Okay, so before we get started, so we want to explain you on some of the OpenAI capacity on the AI service. So these are some of the common ones. There's obviously more. So some of them is like Azure OpenAI service. Can you hear me? Oh, good, cool. So Azure OpenAI service is a service that allow you to have modules that let you interact with other applications. You can have like GPT 3.5, GPT 4, and you can use it with different modules and build solutions like your AI conversation bots, other things. So, and as well, like AI search is like a search capacity and retrieve information that let you index large amount of data. While Azure AI content intelligent, it let you search through unstructured data. It's like, for example, database, that's lots of information, and as well as there's also Azure AI content safety that let you, it's a feature that help you reduce the risks in your service as well in OpenAI. So what's currently in preview is AI Studio. So AI Studio is like a platform that let you build, deploy generative AI, like OpenAI after all. It can include all the features of it, so it can have other things like machine learning in AI Studio. Okay, so how to interact. So to get started, how to interact with AI service. So like other like developers and things, we use different kind of ways like API, SDK to interact it, right? So we use API. So API is like a method that you use to interact with it. So you can use it with different services like Python. I think you can do it with C as well. So, and you can use, there's always some extension VS Code as well. So there's also SDK. So you can use SDK as well as other, you can install it locally, test it, build it as well. So to connect to it, you just need a key and endpoint, which you can see on your OpenAI here.
It's worth just calling out that one of the things we'll show in Terraform is those keys, those endpoints can be extracted as data items.
Yeah.
So you might run some code to go and deploy something and you don't know what those endpoints or those keys are until it's been deployed. Well, Terraform can tell you that information. So as part of your deployment, you have the here and now, and there's normally a missing piece. You would need to get that information before you can move to the next stage. Yeah. Or with Terraform, you can get that information.
So it's the same, you still have to secure that key. So you can secure it numerous ways like key built.
Obviously a range of studios, SDKs, APIs, various different programming languages. What's really interesting about some of the stuff that's been developed here is it's been developed so that you don't have to adopt in a standardized way. You know, the models are there, the services are there, the features are there, and they are there in a way that you can consume them and how it works for you. So there really isn't time to go through all of this stuff in a 30-minute session. It could probably be days worth of testing, but have a look, see what you're doing, look at what you're working with, and you'll probably find there is an integration method that suits your current use case. Usually two kind of common scenarios for deployment. So certainly what I tend to see at the moment in my role as a solution architect, everything can be kind of categorized in these two ways. One is extending in-house or in a business existing applications and bringing those Azure AI services in. So we've got an application that does X, Y, and Z for our business. It might be it allows customers to talk to us, and we want to put some content safety in there. We want to tell somebody, go away. We're not going to talk to you if you're swearing at our staff or something like that. Or we want to extend something else. We want to do some checking that when Jake puts his expenses in, he's not claiming 5-star hotels every night. That sort of stuff. Extending those applications. But also there's a huge amount of development of new applications. So people are looking at these services and saying, actually, I've identified a brand new use case. They're starting that development and they're starting that testing as a result. Nick's going to run through a real world example.
These are some of the real world scenarios that we could want to explain to you. So you can use AI integrated in your solution to build like a question and answer chatbot. So that could be using machine learning to be like more of a customized one to help developers use it as well. So if developer asks some quickly question and answer frequently, you can just reduce the repetitivity by just customize it more, and then you can integrate it with, like, for example, Azure OpenAI, Slack, which devs you commonly use, and Jira, or you can do it with Azure DevOps as well. You can also use it to build in your private OpenAI to query your SharePoint documentation. So if you can use it for your company have an internal SharePoint, you want to query all the contract your client have and stuff, you can query all those things. So it's like an internal chatbot. You query all the intranet, the SharePoint, which is quite a solution that I think of. And you can use it to build, primarily, OpenAI is very good at Python. So it's like you can use it for lemma indexes, streamlets, to upload or ask questions based on it. And it's very good because it's like similar to LLM. Have you heard of LLM? It's like language modules as well. So you can use it. And one of the great solutions that we kind of looking to integrate OpenAI with my workplace is how you can use it with reviewing pull requests. So if you got lots of like pull requests from developers, they were able to organize it to make it easy to read for people who can use it. Yeah, so that's okay.
So when we talk about how Terraform can help, I suppose it's worth caveating other tools are available. I was talking this morning about using Bicep as well, but we're just going to cover kind of Terraform in this. So one of the interesting things, and sometimes I'm challenged by people that say, Terraform's great, you can build infrastructure, but where does it come in for AI or OpenAI or other services? Well, usually that's baseline infrastructure. It's the supporting resources. AI services are rarely deployed in isolation. They need supporting things around them. So one of the ways Terraform can absolutely help there is to do that in a repeatable way. You can build something, you can build a particular application, particular piece of infrastructure, and then you can do that. Do that deployment in multiple ways, multiple times, which is great if you're doing the same thing, or you perhaps have an architecture you deploy for your customers. Something else, this applies to pretty much all infrastructure as code tool sets, but deploying similar infrastructure blocks to multiple locations, multiple regions, multiple different deployments, prod, dev, test, customer A, customer B, your lab environment, that sort of stuff. So there's a huge sort of win there for having that particular way. It also allows the infrastructure, the AI infrastructure, supporting resources, the applications integrated to it, to actually be managed, controlled in the same way that you would do perhaps with software, for example. So you can have that code in a Git repo, you can use pipelines to deploy it, you can use version control, releases, all of the sort of stuff, that perhaps if we turn the clock back 10 years, of a Nirvana state, it perhaps wasn't as available. So talking about how Terraform works, not familiar. It's an infrastructure as code software tool. It's made by HashiCorp. It interacts with a wide range of platform environments, and it does that using providers. So Terraform is the tooling, the software, the language. The provider allows it to talk to that target API. If you're doing that with Azure, it would be the Azure RM provider. Can be used both in cloud and on premises. That's sometimes not something that people are aware of, but there is a VMware provider, for example. You can use that to talk to your on-premises VMware estate if you have.
Yeah.
Three main varieties. Everything we're doing today you can do in the community edition, so it doesn't cost you anything. But there is a cloud offering, a hosted cloud offering, and there is an enterprise version should you wish to host that.
Cool. So these are some various options that you can use when deploying OpenAI or any AI services. So you can use it to create. You can use to create registry or use modules. For example, this module you can use the basic OpenAI accounts. You can create it, and you can use it to interact with. You can use it to create with Terraform as well, and you can use other resources like Azure API, which you have any for new modules, new service in Azure. That's not released yet, so you can use Azure API to connect to it. And one thing I know when using Terraform is that you always have to test those modules and stuff, and you always have to pin it correctly. So just to avoid any breaking change that you have in your module as well. Right, better flexibility.
So bear with me whilst I seamlessly switch. You can tell how slick PowerPoint and StreamYard skills are.
So yeah,
is that still appearing on the screen?
It is a Terraform registry, so it gives you all the links. It's a documentation from how to code, which help you like learn Terraform. So anything you don't know, get it from here, like arguments and stuff, data and stuff. So you have all the resources in different provider like AWS, Azure, Google as well. So all these are different arguments. So these are just like data and the output. So data is only one connected to a resource that's been created already.
So this is a good example of what I was talking about at the beginning, where you might not know the key for accessing a resource. It hasn't been generated until that resource has been created. In the case of Terraform, we can actually output that. The access key can be outputted as a data item. That can then be used further on in the pipeline, further on in the deployment, or it can be brought in as a variable to a deployment later on. So just a really good example of how Terraform kind of gives you that ecosystem to work in. It's worth calling out as well, any resource you can create in Terraform. So I'm working with the back to front mouse here because the way the screen sharing is. So, you can find it within this registry and everything is documented. Every single resource has a fully workable example. So you don't need to sit there and try and work out how to do that deployment, how to piece things together. You can go to that example, copy the code, paste it into Terraform, VS Code, do that deployment. You don't have to sit there and work it out. So it's a very, very powerful place to start if you're sort of looking to, learn more about Terraform, really.
And normally, if you put your key, like access key for OpenAI, you put it in Key Vault and you just query it using those Key Vault credentials resource. So let's use those.
So here's just an example environment. This by no means perfect environment. This is literally me playing around with some icons in PowerPoint for half an hour, but it's designed to give you an idea of what. Take this with a pinch of salt. It's a very high-level overview, but with Terraform, you have two things you could create, and you'll see those two boxes just in the middle. So we can take a Terraform deployment, some infrastructure in that deployment, things like VNets, public IPs, gateways, firewalls, key vaults. Perhaps we need to generate a service principal or something like that. But also, using the Terraform provider, we can generate those Azure AI resources. So if we have an existing process where we're building out infrastructure in Terraform, we don't need to change our practices and processes to do that. Azure AI resources, we can bring those into Terraform as well. So in this example, that box labeled number 2 would probably be all you would need to add. If you're already deploying and managing your infrastructure in Terraform, great, we can bring those AI resources in as well. So yeah, hopefully that just gives you an overview of what that looks like.
Yeah, it's just like a breakdown. So it's like, this is your OpenAI service, and these are what support it to help with the back end of it. And these are just like front end, what you normally would then user would use.
So it's time for me to
We're going to show you a demo.
Pray to the demo gods and probably
That works.
You'll also me sweat in a minute because it'll probably get horrendously wrong. It's worth just pointing out the code I'm using is available. You can download that code.
Yes,
it's
we'll share it afterwards.
So if you'd like to use that, please feel free. Just
sharing the
Sorry,
screen.
yeah, I'm just bringing it.
I have to zoom in.
Yeah. What's this stuff?
This is command.
Yeah, I think it is.
Yeah, cool. Can you all see that? Cool.
So this is just an example of some Terraform to deploy some Azure OpenAI resources. We've got a resource group being created. That's lines 1 to 5. Interestingly, and another feature, and I waffle on about this, that's probably the politest way of putting it, to be honest, when I talk to colleagues. Randomization is something you can do very, very well in Terraform. So you'll be aware of things like key vaults have to have unique names. Well, in the case of some other services, they randomization as well. You can't have multiple. What I'm actually doing here in that line 6 to 9 is generating a random ID. The random doesn't have the same name every time. So I could actually give this file to 30 different people. They could all go and do the deployment, and all of their resources would have unique names. So it's really interesting because, when I first got used to using Terraform, I actually handed some files to a colleague. The first person that deployed it said this works really well. The next person was like, yeah, it's telling me this already exists. Because the names weren't unique. So that's just something to be aware of, but it's worth just covering. Terraform is very good at that. We're also creating a cognitive account. So that cognitive account you can see being built here. Actually doing some stuff here to do private networking. So in this, you'll see it's got the cognitive account. I'm actually in deployment, deploying an OpenAI GPT-3.5 Turbo, the embedding model, and I've also got some private networking stuff going on down here. Now, in the case of this code, and if time constraints aside, when you have a look at this, you'll see there's 2 deployments. One has private networking, one doesn't, and it's just a variable that switches between the 2. Now, private networking is something you definitely want to consider if you're looking at any sort of production deployment. Keep it isolated, keep it private. There's no sort of public risk of somebody getting in at that point. So you can see here, this one has got private networking. It's got a virtual network and a subnet figured, and we've got a service endpoint just down here on line 104 for the AI resource. Bear with me, I'll just switch them.
Show them the code. No, playground.
So you wouldn't think it's so difficult to have one screen that way and one that way and move.
Okay.
So this is a very simple deployment. This is what it's deployed. I know it looks like a lot of lines of code to achieve that, but bear in mind I've got some duplication because of the private networking. But it's deployed as an Azure OpenAI deployment here, and we've got a basic VNet. So we have everything we need really to start doing some testing to this. Let's see. We've got the keys, we've got the endpoints that we talked about. All of these are available as items within Terraform. We could pull those out, we could use them in if we needed to, and it would just give us the access, to actually use those in future deployment if we needed to. From a networking perspective, you'll see here we've got some restrictions. So Terraform's actually configured that for us. It said only allow access to this model from this selected network. If we go to the chat playground, down a little bit, and I actually start, so I'll say something simple. Tell me about Berkeley, London. Come back and say no. And the reason is that's got networking configured, so that's exactly the response we want. This is a public service, and we've said no to any services that don't originate from that VNet being accessed by it. So if we go back here, for example,
Enable that.
That'll take a few moments to do. Then effectively we'd then be allowed to communicate with us. Just a good example of very basic things in Terraform that build in that security.
Yeah, you can further improve the implementation of the OpenAI by integrating it with like web apps or a storage account, adding Key Vault on it, Cosmos DB as well. And then you can put your web app as in your front end, and then just whitelist that per IP address. So that's some of the scenario that you could be using for as well.
Just conscious of time and before I spend the whole day talking about Terraform with everyone.
Okay. So when you get started with OpenAI, you first need to get access to it. So you can get access to it using that link, and you need you can deploy a module. Like when we mentioned, we deploy Turbo. Is it a 3P Turbo?
It was, yeah, 3.5.
Yeah, and then there's thing newer module like GPT-4 as well, and you need certain thing in order to query your private information. Like you need a search index. You know, mention that you give your search capacity, like you query for your private documentation, whether it's PDF, stuff through like the storage account. So this is a high level diagram that we want to show about landing zone. So if anyone know about landing zone, so landing zone is like a architecture diagram that have lots of like governance, securities. It's like a pre-built document, pre-print environment, but easy for you customer to use as well. So think of landing zone like a house. You need a foundation of the house, and each of the thing will be like your doors, your things, each of the service. So in this scenario, we have AI service subscription as a separate section of the landing zone. So it could be like a separate separate room in a house, and you have different services as well. We have storage account, private endpoints, and then we have everything. We break it down a bit.
It's worth calling out as well, there's no reason why anything like this can't be done in code, can't be done in Terraform. You can build things like your web app at the front end of your application. You can start building out the gateways. You can start doing policy. You can do those private endpoints. All of that can be brought into your Terraform. So use this as the reference architecture. Let this do the hard work for you. Well, hopefully that was useful. Or breathe a sigh of relief, but there is some further reading.
Yeah, so if you scan this barcode, you got any links to the documentation, any documentation, links to the GitHub repo as well. And thank you.
Thank you. We'll be around if you have any questions, but yeah.
Good barcode.
Thank you, Lindsay. Yeah, I can't. I was just managing other things sitting there for the other speaker. So, but looks like we had a great first talk from the day from both of you. Thank you for submitting to our event and then
Hello, welcome back everybody. We've now got a talk that I'm actually really looking forward to from John, who's going to be talking all about blob storage and maybe some of the unknown tips and tricks that I didn't know. So John, over to you.
Great. Hi. Well, thanks for having me. And yes, today we're going to be talking about blob storage, but this isn't an entry-level talk. What we're going to do is talk about some of those features that have been added over the last couple of years. Blob storage is one of those services that they keep evolving over time, and it can be hard to keep track of what you may have missed. So let's start with talking about what is blob storage. Now, when I started working with applications, I would kind of think of blob storage just as a place to put things. So I had an application, it was serverless, I needed to store some files, so I went with blob storage. But really, it's a lot more than that. And today, I work with applications that work with hundreds of thousands of files or blobs. And we have to think about a lot more. Not only do we have to think about how those files are stored, and for cost optimization, we also have to think about how we're going to serve those out to internal users and also the public. And finally, we have to think about data protection, because no Azure service would be complete without a full and comprehensive data protection suite. And that's how we're going to break this presentation up into these three core areas. We're going to go over the features at quite a pace, hopefully not too fast, but the idea is to inspire you to go and have a look, go read the documentation and learn more about these. But before we get too far into it, let me fully introduce myself. My name is John Kilmister, and I'm a software architect. I've been working in Microsoft technologies now for nearly 20 years. I'm also a Microsoft MVP, and you can find me online if you want to ask more questions later. So we're talking about blob storage, but I want to take a little bit of a step back, because blob storage isn't a standalone service. It is part of an Azure storage account. And alongside blob storage, we have queue storage for high performance, first in, first out queues. We have table storage, probably one of the cheapest ways of storing unstructured data in Azure. And we have Azure Files. Now, we could do a talk for hours on each and every one of those, but we are focusing just on blob storage, and I wanted to put it in context. So while we're talking about storage accounts, it's worth just mentioning there are different types of storage accounts. Now, some of you may have a standard V1 account hanging around. You can't create these anymore, but the reason I mention them is because everything we talk about today is not available under the V1 account. So if you have got any of those, it is advisable to upgrade because they're no longer supported. But I thought I'd just quickly mention that before I move on. Then we've got our standard V2 account, and that's what we're focusing on today, and all the features that we're going to talk about are available with the V2 accounts. Finally, there is a premium tier. So when you go and create a storage account, you can select standard or premium. And however, premium is primarily focused on the file shares. So a lot of the features we're going to talk today don't affect premium. So I just want to put it in context before we kind of really went into the individual features. So taking the first section, data storage, we're going to start there. Now, when you add a file to blob storage, it will be allocated to one of the tiers, hot, cool, the new cold tier that we've got, or potentially archive. And you can set that explicitly. But if you don't set it explicitly, it will be given the default tier. And you can go and change that default tier in your configuration settings and set it either to hot or cool. Now, this is actually quite important because there's quite a difference between explicitly setting a tier and leaving it in the default tier. And we'll come back to why that is later. But once we've uploaded our blob, we can then view it and we can change the access tier at any time. So here you can see I've got a blob that was uploaded. It defaulted to hot. That's the reason it says inferred. And now we can change it into cold, cool, or archive. But why do we have these tiers and why are they important? Which one is better than the other one? It's a question I often get asked. And the answer really is no one tier is better than another tier. They're all there for different reasons. So if we take a little bit deeper look at that now, the hot tier, it has the highest storage costs. However, it has the lowest access costs. So depending on your use case, hot tier might be really good for you. If you've got a file or a set of files that are being read and written to on a regular basis, then hot tier is going to be the most effective for you. As we go down, that changes and storage costs become less. However, the access costs become higher. So if you've got something like logs that you're storing, you might be storing those, but you're not going to be reading them that often. So you might be selecting the cool or cold storage tier for that. And it's all about that balance between the storage costs and the access costs. Now that takes us right down to archive. And archive gives you the lowest storage cost. It's about the 10th of the cost of the hot tier, so quite a difference. However, you can't access the actual content of that blob. You can read its metadata, various other properties, but not the actual contents, unless we take it back out of archive. Now, you might be thinking, why don't I just keep moving my files around as I use them? And there's a number of reasons for that. One of them is, in order to get the full cost benefit, you need to keep the blobs in the cool tier for at least 30 days, cold for 90 days, and archive for at least 180 days. What do I mean by that? Well, if we move a blob to our cool tier, for example, and after 20 days we decide that that was the wrong tier and now we actually want to move it up to the hot tier, you're going to be charged for the full 30 days of that being in the cool tier and the new storage cost of its new location. So there's a penalty for moving your blob before that time. That's probably more relevant when we come to archives. So if we think of something like a database backup, so you store your database backup, you think, in an ideal world, we never touch it. So we put it in archive storage for the longest time. However, after 80 days, you realize there was something in there that you need. So you go and retrieve it out. You're going to be charged for the full 180 days it's in there, and and the new location, the new location as well. Now that might not be a problem with an individual blob, but if you're moving thousands of blobs around, it's something to think about. There is also data costs moving between the tiers. So if you are moving a lot of blobs around, do have a look at those as well. Now I mentioned that blobs in the archive tier have to be moved out before we can access them. And that process is called rehydration. And when we rehydrate, we can choose either standard rehydration, which is going to happen anytime in the next 15 hours, or we have high priority at less than an hour. We can actually speed that up. So if we've gone with our standard and after 5 or 6 hours, you don't want to wait any longer, you can upgrade it to the high tier, but we can't downgrade. Now, I said that standard tier, it could be any time in the next 15 hours. So you could be lucky and it could be really quick, or you could be waiting the full 15 hours. So how do you know when it's ready, when it's done? Well, you can check via the blob properties, and you can do this with the APIs or any of the UIs available. But do you really want to just keep going back and checking, is it done yet? So you can actually subscribe with Event Grid and be notified. And that's particularly useful if you're writing an application that allows your users to change the files out of archive or out of archive. Now, I've been talking about moving between tiers, and it's a really useful thing to do. But if we move them manually, we're probably not going to be saving that much money, as the blobs are going to be relatively small. But if we're working with a large amount of files, we want to automate this process. So we can do that with lifecycle management rules. And what we can do is we can say, after so many days, move the file to a new tier. We can also say, after so many days, delete that file. And how we do that is from your storage account, go on the left-hand side down to lifecycle management rules, and this is where you can add them. When you select to add a lifecycle management rule, you get the option then to say what your trigger is. How many days, either since it was last modified or created, do you want this rule to kick in? So you might say, for example, I'm writing log files, I upload them to the cool storage tier as the default, and after 7 days, automatically move them to archive. Because a log file, you're probably going to access quite a lot initially, and then you just want to keep it for long-term storage. So that's just a scenario where lifecycle management comes in. Sorry, I've gone ahead a little bit. So you put in there, created 7 days, and then select that you want it to be moved. So once we've done that, there are scenarios though where you want to go beyond last modified or created. It's a little bit hidden, but if you go back to the original screen, there is a checkbox that says enable tracking. What this will do is when you tick this box, it will add in an extra option, which will allow you to base your rules on the last accessed date, which can be really useful if you've got files in hot storage, people are accessing all the time, but then it kind of tails off. Then you can base it on that. One thing to note though, if you're using this feature, there is an additional cost for adding that tracking in. So do check that. Now, lifecycle management rules have been around for a little while and they are really useful, but announced a couple of months ago are storage actions. And they're very much like lifecycle management rules, but they give you so many more options. There are so many more triggers. There are also so many more things you can do once that has been triggered. You can also put in multiple conditions and you can put else statements in, and it really builds on the lifecycle management rules with this completely new feature. It's in public preview, only available in 2 regions at the moment. If you want more details on it, I have a blog post on my blog, which will cover it in more detail. Let's move off that now and talk about some of the other things that we can do with blobs. We can add extra data. I mentioned about metadata earlier. Well, there are some built-in properties that we can work with. And if we want to put our own data in there, we've got the option of putting key value pair data against the blobs, either as metadata or as blob index tags. And if we use blob index tags, then we can search on it later. Now, one of the more sort of behind the scenes things that people don't realize is that when you add a blob into blob storage, it can actually be of 3 types. So by default, if we don't specify anything, our file blob is going to be broken up into multiple blocks. And when we upload the file, we can specify the size of those blocks, and we can have up to 50,000 blocks. And this is really good for uploading files because those blocks can be uploaded in parallel, and they can be uploaded in any order, they can be updated in any order. So it's really optimized for uploading large files. And that's the default if you don't do anything. This is particularly important when we come on later to talk about some of the cost factors as well. The maximum size of an individual block, by the way, is 4 megabit. Is 4,000 megabits. I got my words mixed up. So we've got a different type of blob as well, which is the append blob. And in this scenario, the blob, the actual parts of the blob have to be appended to the last bit. So this is particularly good if we're streaming large amounts of data up. Now, updating the previous blobs you've uploaded, isn't supported. Finally, we have page blobs. And if you've got virtual machines that have a disk that's stored in storage, this is what it'll be using. And it's really optimized for reading random parts of that blob. So let's talk about data access now, because if we put our files into blob storage, that's not much use if no one can actually access them. And there's many different ways to access our blobs. The first one, if you've ever worked with blob storage, you've probably used this tool, is Azure Storage Explorer. And it not only allows you to access your blobs, but actually anything in that storage account. It's a cross-platform, open source desktop application. Now, this tool allows you not only to upload and download your blob, change the tiers, but you can also look at previous versions, snapshots, and many other things. I've actually been using this tool slightly less recently. I still use it when using the storage emulator for local development. However, inside Azure, we now have access to a storage browser, which has the majority of the features. So just from your storage account, you can go down to storage browser, and you have the ability to do all the things that I've just mentioned. Moving on quickly from that is a command line tool called AZ Copy. And this is optimized for working with large amounts of files. There are many things that you can do with this tool. And again, it's cross-platform and open source. And actually, it's used by Azure Storage Explorer. When you upload a file, it's using AZ Copy in the background. So what I'm going to do now, though, is focus not on the things like tier changes or uploading a single blob, but give you a bit of an overview of some of the more advanced features of it that you might be interested in. The first one allows us to copy a local folder up into a container, but we can filter out certain file types. Now, because this is a command line tool, we can use it in a CI/CD process, we can use it in a PowerShell or Bash script, so it can be really powerful. And I'd say it is optimized for working with large amounts of files. when working with large amounts of files, you might want to change the block sizes. So we talked about the blob being split up into individual blocks. Well, with the benchmarking tool, you can see what effect that might have on your upload and performance speed. We can also do a remote copy, so we can copy from one container to the other without downloading all the files first. So particularly useful if you've got a lot of files up there. But we can also use that remote copy to copy from an AWS bucket across, or from a Google Cloud storage across into Azure Blob Storage as well. We can do a local sync. So we can take a folder locally and make sure that it matches what is in your storage container. Now, everything that happens inside AZ copy is actually a job, and that means that it can be paused, interrupted, and you can do various other things. And we can see the jobs that are running through the AZ jobs list command. And finally, if we need to resume any of those jobs, we can do that with the AZ jobs resume command. This tool does an awful lot. Pretty much anything you can do with blobs, you can do with this. And as it's a command line tool, as I said, you can use it in your scripts and CI/CD process. So particularly powerful. I won't go into it in any more detail because we don't have time today, but do check it out if you are working with large amounts of files. However, both this and the storage browser require the people interacting with it to have an understanding of Azure. What if that's not the case? Well, we can in fact enable SFTP on our storage accounts. So, however, by default, this is hidden away. So if you go to your standard storage account, you won't be able to see the SFTP option anywhere. And it's because the hierarchical namespaces are disabled. I won't go into what hierarchical namespaces are at the moment, but if you want to speak afterwards, we can talk more about that. Point is, for SFTP, we have to enable them. And once enabled, we then get a new SFTP option on the left-hand side. It's still turned off at this point, but we can navigate to it and enable it. Now, it's quite an expensive service. It's charged by the hour. So it's designed to be turned on. You upload your files, you turn it off. And helpfully, more recently, they've added in a little warning to tell you this, because I got caught out by it the first time. But it is a useful feature, especially if you've got external people wanting to upload files. Another way we can share our content in a storage account is through a static site. Now, we've obviously got the Azure static web apps, and you might think all focus has kind of gone from the storage account static sites, but actually they've been adding more features to it. If you haven't come across this before, when you enable it, it creates a new container called $web, and any files you put in there will be accessible via a web browser. I've used this for sharing CSV files publicly, for example. So yeah, it's a really quick way of sharing your container content publicly through a web browser, so people don't have to have any Azure knowledge or Azure things in detail. Now, I briefly mentioned there about Azure Static Web Apps, and you might be thinking, well, why would I bother doing that when I could just go and use an Azure Static Web App? Well, storage accounts have now got improved SSL certificate management because it's linked in with Front Door. And you get caching and custom domains and a load of other great features. You can set default documents and error paths. However, if you have a full JavaScript application, Azure Static Web Apps are going to give you much more. It's going to give you page redirects. It's going to give you integration with Azure Functions and a load of other things. The standout reason for me why you'd want to use the static sites on Azure is the direct file access. If you're using Azure Static Web Apps, then the way it works is that you have a CI/CD process. You take a JavaScript application, it does a compilation of sorts, and then it publishes it up into Azure Static Web Apps. You cannot get to those files in that static web app to directly look at them. So if you're in a scenario where you want to look at the files and actually manage them individually, as I say, you might have a list of CSV files and you just want to keep uploading them and give people access to them, then this may be a better solution. So going back to other ways that we can access the data, access keys are probably one of the most well-known ways of accessing data. But these will give you access to the entire account. So you have to be very careful what you do with these access keys. There are still scenarios where you will want to use access keys. However, it's no longer the recommended way of getting access to your account. One feature I did want to point out, is this little button up here, is about setting the rotation reminder. So if you are using keys, you can enable that. It will put a banner across the top of your storage account, prompting you to rotate your keys as you should do on a regular basis. So what's the alternative? Well, that's SAS tokens. And if you've done a lot of work with blob storage, you're probably quite familiar with these. But if you haven't, what they do is you set a permission, you set some settings like IP restrictions, start and end time, make it as restrictive as possible. And then it's going to give you a token. And that token can be appended to the end of a URL to give you a full path to it. And we can use that in Storage Explorer. We can use it in AZ Copy. We can use it with any of the APIs. This can be done for storage containers as a whole or individual blobs. It produces quite a long URI with the signature. Now, stored access policies are a little bit more hidden away. And what these do is instead of creating a lot of separate SAS URIs, what you can do is you can set a policy which groups all of those together under a name. And then when we generate our SAS, we can point at this policy. So then this policy can be used in multiple locations. The most common way of accessing these files, though, in storage are probably through the actual APIs. And I thought it's worth mentioning just how many SDKs and client libraries we have that wrap these APIs. So pretty much no matter what language you're using, you will be able to use all of the features that we're talking about today through your languages that you use. There's so many other data access features. We don't have time to go through them all. I'll do a very quick summary of these, but if they are of interest, definitely go away and have a look in more detail. So blob leases allow us to take an exclusive lock on a file. So you take out a lease, and then any further commands that you want to do with that file, you have to provide the lease ID. Anybody else who doesn't do that will be locked out from it, and then you can return that lease once you finish. So if you need exclusivity on a file, particularly useful. NFS 3 network shares for Linux are available. Again, you do need to enable hierarchical namespaces for that to be available. We can hook it up to Azure Search, which allows us to index the documents and files that are in our storage account. If we're moving a lot of files around, it is worth having a look at Storage Mover. There's a lot of documentation on it, but if you're doing, say, for example, an on-prem migration, that is a tool that is worth looking at. And as with Azure, every Azure service, we get free metrics. So this will tell you things like how many blobs you have in each tier and various other things. So if they're interested, do go away and have a further look. So the third and final section I want to talk about is data protection, because no Azure service would really be complete without that layer. And the first thing I'm going to talk about is replication. And you might think, well, I always select replication every time I create the account, and I either select the cheapest option or the most expensive option. But let's have a look at what it's really doing behind the scenes. These screenshots are directly from the Microsoft documentation. There's a link at the bottom, but I can always share that later. That give a lot more detail on this. If you select locally redundant storage, the cheapest option, 3 copies of your data are actually available for you behind the scenes. Completely transparent to you, but there are 3 copies. If we upgrade that and we pay a bit more, we get zone redundant storage. So that's going to put it in 3 different availability zones, protecting you against some of the infrastructure outages, such as power loss. But you still have 3 copies. Again, completely transparent to you. Then, if we step it up again, we can go to geo-zone redundant storage. And now you get 6 copies. You get 3 copies in your primary data center and 3 in the secondary. But one of the lesser known effects of this is that you will still have an outage, will potentially have an outage if your primary data center dies, because it has to realize that it's not available, and then it will do a failover to the secondary data center. So you might have an outage during that time. So although your data is protected, you have that. And the way we get around that is with read access geo-zone redundant storage. I didn't make that name simple. Now, that allows us to read from the secondary location. But again, something that's not obvious is that you actually need to change your software, your application that's reading it, to make sure it can read from both locations. Because if you just select RAGZR access and you don't change your application, it's going to continue to read from the primary and you're not getting any of the benefit of having that secondary there. So yeah, there's a load more detail about this, but it is well worth the read. The SLAs are also different, by the way. It's 99.9 for all of the replication types, but if you add in that read access geozone redundant storage, it goes up by an extra 0.09 to 99.99. But all of that's in the documentation. So that's all good if we've got a hardware failure that's out of our control. But what if someone goes and uploads a blob that and overwrites something that you've already got there? That's quite a common scenario. Well, we can now enable blob versioning. So it's a checkbox in the data protection section. And then every time that blob is modified or a new version is uploaded, the old versions will be kept. And we can actually view these old versions in our storage browser by going down to view old versions. Now, as far as charging is concerned, remember I talked about blocks right back at the beginning and how your blob is split up into the different blocks? Well, you're only charged for the delta between the two versions. So this will matter. If you've created those blocks to be really large, it might have an impact on this. So that's why it's good to understand how those blocks are created. But sometimes I don't want to create loads of versions because, well, after a year or two, I might have like 200 versions. Well, firstly, we can clear up those old versions using the lifecycle management rules. So in lifecycle management rules, you can say, I only want my rule to apply to versions as opposed to the actual blobs themselves. But still, you might end up with a lot. So instead, we can take ad hoc snapshots. And snapshots work pretty much the same as versions, but they are manually taken. I say manually, you can automate it through the API, but it's not going to be automatic for you. Snapshots for hot and cool tiers only. So archive doesn't really make sense. And as I said there, you are billed for those unique blocks. There is a caveat with being billed for those unique blocks, and that is if your version or snapshots are on a different access tier than your primary blob, then you're going to get charged for the entirety of it. All of these things I'm talking about costs is definitely worth going away and looking at the pricing page and getting a full understanding of it because they are particularly complex. So that's good if someone is overwriting your blobs, but what if someone goes and deletes your blob? That's not going to be captured by this. So that's where soft delete comes in. And soft delete now is in the majority of Azure services. And we can have soft delete for blobs, the actual blobs themselves, the snapshots, the versions. It's configurable. But as with most things, you're charged until it's completely removed. There are so many storage features and so few minutes left. So I'm going to quickly go through some of the others that you might want to check out. We have immutable storage. So if you create an immutable storage policy, then those blobs that are affected by that policy cannot be changed in any way. So it gives you protection, and that can be really good for compliance reasons. We have a full point-in-time restore. We have Azure Backup. We also have change feeds. So if you enable change feeds, you get an extra file, which will be appended to every time something changes in your storage account. And then finally, we've got Azure Defender for storage. Much like many of the other defenders, it is there to detect threats on your storage, in this case, in your storage workloads. And that's going to include the data, malicious access, and potentially any sensitive data and malware that's uploaded. So a bit of a whistle-stop tour of many different features that we have in our storage accounts, from the data storage to how we access it, all the way through to data protection. So thank you for listening to me, and hopefully you found that useful.
Was wonderful, John. I think there's a lot of practical information that we all can take away from your session today. So what about questions? Does anyone have any questions for John?
Can you go back to the last slide?
On that?
I just want to...
Yeah. I can take any other questions. Or you can always see me afterwards or my contact details. I'll put back up at some point.
Absolutely.
Thank you.
Thank you so much, John. So let us have a 5-minute break before we set up Marcel, our next speaker. Thank you once again, John. Great to have you here. And it's a 5-minute break. Thank you. we are back with Marcel, a friend who is going to be speaking about Azure verified modules. Marcel, good to have you back at Global Azure Days London 2024. The stage is all yours.
Thanks for having me. Alrighty. Thanks for everyone for coming today as well, taking the time out of your day for the Global Azure event, and thanks to the organizers, Callum, and everybody that was involved in arranging this. So my name's Marcel. I'm a DevOps MVP and also do solutions in DevOps architecture. And today, there's some of my details. But today what I want to talk about is Azure Verified Modules, something that came out very recently. And also just to give a big shout out to the Microsoft team, Matt and Jack Tracy, who's like actively involved in this initiative of Microsoft. So a big shout out to them as well. Just out of curiosity, has anyone ever heard of Azure Verified Modules in the room, or is it totally new? Yes. Yeah, it's quite new. It's so I'll just jump straight into what the agenda is that I'm going to show today. Just going to give an introduction on Azure Verified Modules. Basically, what are they? What is the challenges with writing infrastructure as code? The benefits of having modules that is curated by Microsoft, which is the Azure Verified Modules. And we're going to look at some of the consistency and features, which I call interfaces in these modules. And then I'll just do a short demo just to show you how you can get started and start using this in Terraform. So what is Azure Verified Modules? So basically, like I said, it's a set of curated infrastructure as code modules that is developed and kind of looked after and maintained by Microsoft. It's compliant with a lot of the team that is involved in this is from the well-architected framework in Microsoft. So they create these modules based on best practices and based on the well-architected framework. They're designed basically to build secure, scalable, and resilient cloud environments. And at the moment, there's two languages which are supported, and it's Terraform or Bicep. What's nice about them is they're uniform, and we're going to have a look at the design patterns and framework for that uniform and consistent configuration options available in these modules. And basically the features, which is called interfaces. So just, we'll go more into that in a minute. So what are the challenges with writing infrastructure as code? Just a quick question for the room. Who does write infrastructure or code, or does platform deploy projects? And so there's quite a few. So you've probably, if you don't, you probably have a DevOps engineer or a platform engineer or SRE to basically deploy that infrastructure using some sort of infrastructure as code technology like Terraform or Bicep. So some of the challenges with that is basically the effort that it requires to maintain modules, especially like in fast-paced environments like Azure, where there's new things coming out all the time. There's changing, stuff changes, a lot of innovation and stuff. You just have to kind of keep up your modules. And it takes a lot of effort and time to kind of, before, your modules could go kind of stale and things like that. Now, there is also the Terraform registry, specifically in the Terraform side, where there is a big community of developers that create their own modules. And sometimes, even Microsoft would create a project there, which would have been maybe a pet project or something that got maintained and then stopped being maintained. So there's quite an abundance of kind of almost these registry modules that you can kind of go and look and start using. But it's a bit risky because there's some uncertainty whether those modules are going to be upkept. Or then as well, if you're writing your own modules, upkeeping them yourself, the effort that's involved. So that's where Microsoft started the idea of Azure verified modules, where they've actually put a team, full-time employees directly supporting, creating and developing these modules. They undergo, for testing to making sure that their functionality is always up to date with the latest features. The modules, all of them has a consistent design pattern and framework, and we'll have a look at that, which they call interfaces. We're going to have a closer look at that in a minute. And what's also nice is the default. So if you use Terraform, you'll know that you can have, for your input parameters or variables, you can have default values. What's nice about these modules is Microsoft, because it's the well-architected framework team, they'll always keep the best practice in a default value. So if you forget to put a value in, they try and tend to populate the values with a setting, so you don't have to give the setting, but all the settings are configurable. But what is nice is they're done based on best practice and not by someone outside of Microsoft. So it is catering for Microsoft by Microsoft to kind of maintain these modules. So that's kind of quite cool in a way. Now, when I talked about interfaces earlier, and in these modules, they have consistent configuration, which means if you're building a storage account or a key vault or these different parts of the resources, there will always be cases, especially in a corporation or in your business or in your company, where they want to follow certain practices and rules. So for example, maybe the key vault needs to be on an internal network. The storage account needs to be on an internal network. So it's not just building a storage account or something like that. You have to also then now think about private endpoints and building those things and maybe diagnostic settings. So what Microsoft has done with these resources are basically creating the resource and then building plugins or these interfaces in as part of a resource, which makes it more of a service, which you can then, which is uniform across modules. So you can deploy, for example, your storage account with diagnostic settings, if you choose to do so, with role assignments, with locks, with tags, managed identities, private endpoints, customer managed keys, or even alerting. And that is kind of all part of the module, or these interfaces. And it's just following a consistent pattern, so that when you deploy a storage account and you deploy then something else like a key vault, you'll still have these interfaces and they'll be called the same thing. They'll be the same type of object. So for example, when you give a configuration, it'll be a list or a map. These objects are all the same across the different modules. So you can just copy the code for your storage account and just simply change a few values, and the code will make a lot more sense across a large spectrum of an architecture or a thing that you're building, solution that you're building in Azure. So I will go into a demo, and also there's some QR codes here for you to look at Azure verified modules. We'll look at that in a sec anyway. But there are two types of modules that Microsoft is doing here. There's the resource module, which are basically things like a storage account, a key vault, a log analytics workspace, with all of these features. And that's almost like a service of that resource, rather than you building all the resources around that, and then the next thing, and then building all the resources around that. They're more of a combined resource with these optional configurations or interfaces. Those are what's called resource modules. There's also pattern modules, which is for anyone who's looked at the Microsoft well-architected framework or architected center, there are a lot of architectures, reference architectures, like, for example, building a production. What is a production scale AKS solution looks like, and then you can look at the Architect Center for Microsoft references. So they're on module or a landing zone, for example. So when it comes to pattern modules, Microsoft's developing these almost like reference architectures as a module that you can also use rather than using the building blocks of those resources. But we'll go into that a little bit. But just to show you a little bit of what this looks like in terms of when you want to get started. So I've got a GitHub repository where I don't know if that's visible to everyone, if that's okay. But basically, I've created a GitHub repository where I'm just going to deploy a few bits and show you what these patterns looks like. So, for example, we always start off with a resource group. And then because I'm going to use private endpoints, I'm creating a network with a couple of subnets. My network's got a common subnet, a data subnet, a compute, and a web subnet on a small range, just building a network, and then setting up some private DNS zones for my private link for these resources. Now, when you, if we go to, for example, a storage account, so these modules are accessible in the Terraform registry, and I'll show you some more details of where you can get hold of these modules and try it out for yourself as well. But if we just look at the pattern here, so you can build a storage account with all the normal settings that we can set. So, for example, the access tier, the kind, the location, things like that, which is more about the storage account itself. There's also an interesting value called telemetry, which I'll go into in a little bit here, which is called enabled telemetry. I'll explain that in a few moments. But here is now where I create my, for example, my identities. So managed identities will, I can have a system identity or a user assigned identity, but that block is going to be uniform across all my modules, that interface. Same as private endpoints, you'll see that it's a map configuration of a certain pattern or standard with the name, the subnet ID, the sub-resource, the private DNS zones with all those settings. But again, that private endpoints configuration or map is going to be uniform across my different modules. Same with role assignments. And what's also actually just to go a little bit into that, in the private endpoints configuration, you'll see there is a role assignments configuration embedded inside of that private endpoints. And then you'll see a role assignment interface that is outside, which is part of the storage account. And this is basically if I want to give access to my storage account as part of deploying the storage account. But maybe my private endpoint, I want to give a different access, like a reader or something like that. So that will then, I can assign a role assignment inside of the almost interface. And you can change tags as well, and the interfaces are kind of embedded and nested into each other. But in the end of the day, it's one module, it's one service that is kind of catered for storage. So if we, and I'll show you what that looks like in Azure in a moment, but just to show you with Key Vault, for example, same pattern is basically being followed. So you have your default Key Vault settings like location, resource group, what sort of Key Vault you want, SKU, things like that. But then again, you see that private endpoint interface has got the same design pattern with basically. Oh, zoom in. Oh, yes, sorry. I'll try and make that a little bit bigger. No, it's difficult to see. Is that better? More?
One more, yeah. Yeah, that's fine.
Okay, perfect. So let me just See if I can make that a little bit. That. Yeah. So again, if I just jump back, you see the pattern, it's a map, it's the same pattern. I can give the role assignment to my private endpoint as part of the creating this key vault. And then again, I can do a role assignment. And you'll see at the top here as well, what I've put in is those commonalities of these interfaces. You can do the same with diagnostic settings, role assignments, which we do in here, locks, if you want to have a resource lock, so people can only read or not delete that resource, tags, managed identities, private endpoints, customer managed keys, and alerts. And just one more, just as I thought, just to show you that it is consistent across another one is, for example, a container registry. As you can see again, your build, it's got some settings like SKU, location, things like that, which is pertaining more to the container registry. But then again, you'll see here we've again now got this private endpoint block, which is a map configuration of to private endpoint this ACR, and then also adding the role assignment for ACR pool, for example. For our key vault, it's secrets officer that we're adding an account, and for storage, it's a let's see here, a storage block data reader. Now I've already deployed this kind of basic few resources, so I'll just show you what that looks like in Azure. So for example, if we look at the first one we spoke about, which is the storage account, if we focus on the role-based access, for example, if we see the role-based access control has got that storage data block reader, but if we look at, for example, the private endpoint that was created for the storage, if I can find it here, you'll see that the role assignment on my identity that I used was set to contributor. So you can kind of almost granularly permission these interfaces as well. So what I want to do next is just quickly show you how you can get more involved in or how to use these modules. So this is the site. I think I've got a QR code as well, which I'll go back to, which is basically the landing page of verified modules. And I will go into a little bit more about those interfaces that I spoke to. The documentation is very well maintained and documented by the team in Microsoft. What's also really nice, I forgot to mention about these modules are, like I said earlier, when you are using a community module and there's maybe one developer and maybe the upkeep's not very well, you could log an issue or a GitHub issue if you want to add a feature, or maybe something's not working, and that person might never get back to you, or maybe it's a small team that's no longer maintaining that module. What's nice about these modules is Microsoft's got the full-time employees working on this, and you can log an issue, a feature, a request. If something's not working, you could go to these modules GitHub pages and log a ticket, and it will actively be looked at, and you basically investigated and resolved in hopefully a timely manner. But yeah, so just to show you how to, I'll jump back to interfaces in just a moment. But when we look at the navigation here, you've got Bicep, which is those resource modules. So for Bicep, they've already got 114 modules and one pattern module. Again, pattern modules are things like a landing zone or an AKS production environment, for example. And you can also see which are new modules that are coming into the pipeline. And you can kind of browse through the list and see which ones are working, which ones aren't working. I'll just quickly jump back to Terraform. Terraform's got quite a lot in the pipeline coming. but at the moment there are 28 modules that you can use. And if we just quickly jump into the list here, you can see that, for example, if I go to the storage account module, jump into that, it takes you actually to the Terraform registry where you can get more information on the README or what input variables there are. Again, like I said, those things like the private endpoint connection settings, it's all in here. And if you don't, you'll see here that the required inputs is just the name and resource group. And when I said earlier that if you don't give an input, so say you don't put a certain input or a parameter, Microsoft has populated that default with what the best practice is. So for example, if you'll see here with the replication, it will use the RAG, what was it? RAG ZRS as the, but you can obviously override these. But just to let you know that these defaults are based on basically the best practices and stuff like that. So you can come and jump in here. If there's an issue, you can basically go to the GitHub page. Like I said, these are very well maintained. You can create issues and bugs or ask questions and features for the storage account, for example, or once there's more pattern modules. Microsoft's taking at the moment, with a lot of these modules, you'll see they're at version 0 point something. So there's not an actual version 1 of these modules yet because it's very new. Microsoft is taking a lot of feedback at the moment and seeing how it's being used, and really value almost like community or module developers' input on how this should look and be shaped going forward. So, if you're interested, then get in touch with the team. I think they're very keen to hear on feedback, which brings me now back to the thing that I said earlier about the telemetry. So in these modules, you'll see that I've got a setting which is called telemetry, which is true. And the only reason for this is so that Microsoft can basically almost see how much these modules are being used. It's all private, so you can opt out of this as well. You don't have to share it in case you're, but basically it's telemetry is basically just something for them to measure. And it's all kept in Azure, and you can read a little bit more about that as well on the site here. But yeah, just jumping quickly back to the interfaces. They're very well documented. So when I talked about earlier about, say, private endpoints, you can jump into that. It tells you how the interface works or the configuration for Bicep or for, you pick whether you want to go from Bicep or Terraform, depending on what you're using. And it gives you an example of, oh, is this customer managed key? Sorry, I was private endpoints. Here we go. So you can see there that it's that you create your DNS zone, and then you have this variable that you now can use to, and this interface will look the same across all the modules, the storage account, the ACR, the key vault, whatever you pick. So this makes it really nice because now instead of building your key vault and then the private endpoint separately or whatever you're building, it almost comes together as one service tailored to how Microsoft, how these resources work together, and with almost the resources around them. And I think that's about all I've got on this at the moment. And I'll just put up this slide again here so you can, if you wanted to, have access to the demo repo, which I've created there, if you want to see how to do that, just to play around with, or the Azure Verified Module site. Yeah, I think that's all I've got. Are there any questions or anything in terms of this?
you use it in the pipelines, in DevOps pipelines?
Yes, yeah, of course, yes. You can, so when you're writing your Terraform code, you can have DevOps pipelines or GitHub Actions to deploy that code using these modules. I can just quickly show you, because these modules are kept on the public Terraform registry, you would just access them so I should have shown that. Let me just quickly open my VS Code again. Oops. Bit of delay there, sorry. So you'll see here, when you're writing your module, you can reference the source and the version of the module. And however your deployment in CI/CD is at the moment, whether you're deploying your code through Azure DevOps or GitHub Actions, you'll still point to these module files, and they'll pull that from the public public registry that Microsoft's keeping the modules. Alrighty, yeah.
Yeah, I was just curious because I guess one of the arguments for doing this is that it's done by Microsoft, it's stable, it's maintained, but I couldn't find on the site yet any actual statement about how long it would be supported for, or what the support statement was, because everything's supported until it isn't, right?
Yeah,
if you're going to hinge everything around this, I was just curious as to what advantage there is to this versus homebrew, aside from stable interfaces. If you get
Yeah, and that's a valid question.
Masters, can I
Yeah.
interrupt you for a minute? Could you repeat the question?
Oh, yes.
Our online.
Yeah, sure. Yeah. So the question was a guarantee for how, are these modules going to be looked after in the long term? It's something that's very new, or is Microsoft going to drop it at some point? And you're almost asking, just, is there a guarantee that this is going to be looked after in the long run? And the answer to that is, I think Microsoft has put a lot of effort and resource and people behind this, because there used to be Azure modules before, but they were not really maintained or anything like that. And that's why Microsoft saw this opportunity to almost introduce Azure verified modules, where they're actually putting people behind it. And I think it will be for the long run. Yes, it's very active at the moment. The design of it is very clever, and the patterns, and I wouldn't worry too much about that. I think it will be maintained for the long term, because Microsoft has put that people and invest in that. But at the moment, it is very early days in terms of how this looks, and Microsoft's taken a lot of feedback from that. So based, I guess, on usage and things like that, I'm sure this will help a lot of people. Homebrew modules, I kind of agree with you as well. But it's difficult to find the dedication, because you might go to the Terraform registry and see the same module 20 times from 20 different people, but some might be actively looked after, some might be actively looked after until a point, some might be just like, I don't know, a uni project or something like that. I don't know. Or someone just wanted to play and see how it works, but then leave that project. I guess this safeguards a little bit against those uncertainties, whether, and also like when you're adding bugs and things like that, getting a quick response, because there's actively people looking at it. I guess that kind of helps a lot at the moment with this as well. I hope that answers the question. Any other questions or anything? I think we're out of time anyway. Alrighty, thank you very much.
Thank you, Master, once again.
Thank you.
It's always good to learn something new. Don't go anywhere, because we'll be right back with our next speaker. So Callum is going to set her up, because she's going to be virtual.
Hello, everybody. Welcome back. We are now going to go to our next session, which is about unlocking the power of OpenAI, and it's with the wonderful Alpa, who I believe we also have on the line. See, yes, we do. Hey, Alpa. Hopefully, the people in the room can see you too. Hello. We here.
Hello.
Amazing. Alpa, this is your second time at Global Azure London. We had you last year too, and you had a fantastic session there about, was it Data Studio, I think you did a session on.
It's sentiment analysis using Azure Data Factory.
That was the one, yeah. Fantastic. Well, Alpa, whenever you're ready, please share your screen, present on the StreamYard, and we'll take it away.
Can you see my screen?
We can see your screen. Yeah. See StreamYard. There we go. Fantastic.
Yeah. Okay. So thank you all and welcome to my session. In this session, we are going to see Azure OpenAI and how you can apply, mainly in demo, how you can use in different way, how you can consume it in different way. So this is me. I'm Alpa Budpati and I am working as a data engineer. And you can find me in the LinkedIn, Twitter. I have my blog in Mediums and even YouTube as well. So let's start quickly with what is Azure OpenAI. So Azure OpenAI, we can say it's a set of AI service that allows you to apply a large language model or natural language algorithm on your data without any prior knowledge of maths, data science, or machine learning. So that is Azure OpenAI. And for that, you don't need to be expert in any field. You can start wherever you are. You are DBA or tester or, developer or business analyst, whoever you are, but you can start learning Azure OpenAI and you can make your application more smarter using the Azure OpenAI without writing code for a natural language processing. It's co-developed by Microsoft and OpenAI teams. And because of that, you will have an enterprise level security. It's provide you private links, Azure Active Directory, Azure role-based access control to help you secure your network identity and access. So it's a more and more secure and you can very easily use on your data as well. So now let's see a few examples. So for example, you have a data, maybe structured data or non-structured data or same, whatever data you have, you can apply this on your data and you can do it very quickly and very easily. And you can make your Q&A kind of apps or you can make chat bot or something like that on your data. It also help you to summarize your big data. It's like huge amount of data and you'd like to summarize, then you can use Azure OpenAI. It help you to convert or natural language query. Like for example, you have a query in English language, like what is my finance data or where is the loss today, this month or like that. So you can write down that English sentence and it convert into a query and then you can return your data. So it help you in that way as well. It help you to generate a code, not only code, but you can generate a test cases. You can generate a pseudocode for your business requirements and you can ask to generate a sample data as well based on your scenarios. So you can use Azure Open AI on that situation as well. It also help you to summarize and analyze your media file, for example, audio file or video file, or maybe also image as well. So it help you on that as well, and it save your time. So like if you have a data in your company, you can apply this idea on that. You can use Azure Open AI and you can save your huge amount of time using this Azure Open AI. So now let's see how to consume Azure OpenAI. So first of all, you need to create Azure OpenAI through Azure portal or maybe code, Terraform code or like that. And then you can consume it various different way because when you create it, it will give you a REST URL and key. So that two piece of very important that you can use either no code, low code way or code first way. So you can consume Azure OpenAI through Azure services, for example, Azure Logic Apps, Azure Function, Azure SQL Database, Azure Data Factory, Microsoft Fabric, Power Apps, and many more. And you also can use through a Power BI as well. And if you want to call through a code, then you can have your code in C# or Python. You can use SDK and you can consume through that way as well. So now let's see high level design of Azure OpenAI. So in order to use Azure OpenAI, you need a data knowledge. So knowledge can be private data, which can stored in your blob storage or Azure SQL database or Cosmos DB or something like that. Or it can be from public data as well, data over internet as well. So this is a knowledge. So you need a knowledge and you need to pass this knowledge to here in Azure OpenAI. And you need a query or prompt or input or a problem which you're going to solve, so that you can pass through either directly through user via chat, or you can get that from also database, which is your private data source, which can be like storage account or any one of these. And based on that, so you passing knowledge, you also asking a prompt question, so you have to this information, and then based on that, sometimes it need Azure AI search, sometimes it need when you need to deploy as well, and you need a Python code or some kind of different kind of code as well. So based on your situation or scenario, you can have those services, and based on that you will see a response as well. And this response also you can store in database, or you can do something else, you can save in file, or maybe attach email or something like that. So this is a higher level Azure OpenAI design. So now let's see a quick demo. So here we are using data over internet, that is knowledge, and we are asking simple question, what is 2 plus 2? And based on that, we don't need a Python code, and we don't need even a web apps as well. We can do through via portal, and based on that, you will see a response as well. So if I go to here, so for this session, I have this resource group, and inside I have these resources. Apart from that, I have a Microsoft Fabric and Azure SQL database as well. So let's see it here. So this is the Azure OpenAI. So if you are new to Azure OpenAI, then I have already blog here, and you will know how to create Azure OpenAI. And there are so many other things, how you can build like this kind of the application as well. And you will see more information in here as well. So I'm not going to create in this demo because we have less time, but we already have created, and you can create it by few buttons click away. It's very easy to click. So once you create your Azure OpenAI, it will look like this. And here you can have a model. And these are the two important things we said earlier, key and endpoint. So these are the things you will get it from here. And now let's go to model. So once you create Azure OpenAI, after that you need to deploy a model. And this model is pre-built model. And this is like, ChatGPT or GPT-4 or something like that. It's already there. So you just need to pick model based on your requirements. So first you create instance, and then you deploy model. So that you can do by just here, by few button clicks away. You will select a model which is already there. And then you will give a suitable name, and that's it. So once you do that, you will see you will get models here, and then you can either go to Studio, AI Studio and do, or you can come here and do as well. So here we are mainly focusing on chat area, and here you can see that you have a prompt, system prompt, you have a user prompt, and these are the parameters. Here you can select different model as well, and you can see more parameters as well, like tops and temperature and like that. So temperature, if you're learning new, then you don't need to worry about that to change. Otherwise, sometimes based on your scenario, you need to change temperature high or low, or top high or low, like that. So those are the parameters. And now if I just say, just in order to see it's working or not. So yeah, so it's already deployed successfully. And here you can say what is 2 plus 2, or you can ask whatever you like to ask, and based on whatever information available on the internet, you will get response. So that is one. And so let's go back here. So that is a first demo, is this one. And if you want to call this demo on Azure Data Factory, then I can show you another demo, which is how to call that. So here you can see that in Azure Data Factory, you have a web activity, and in web activity, you can call a REST URL. So here you can see that this is a URL of my Azure OpenAI instance. Here we have to choose the post method, and here you can see a message. So here you can see that system message and user message. So this is a system message that you are AI assistant, but you can say anything. You are a mathematician, or you are a doctor, or something like that. So that is a system message here. So based on that, you will you will get answer. So in here you are asking a question, what is 2 plus 2? So here I said add 2 to 2, and this is a hard coded one, but this you can make a dynamic. And here in outside of your before your web activity, here you can have a lookup activity or something like that, that which can get a data from blob storage or database or something like that, and then you can pass dynamically as well. So that way you can pass that. And these are the very important things. Key you will setting in header, and this is content type. So these are the things you need to set, and you don't need to remember anything. You can easily get that from here. So in here, view code is there. When you create your Azure OpenAI instance and deploy model, and then you will see this view code. And here you have various different way as well. So if you want to call as a OpenAI a REST to URL, then you can see the syntax is here. So you can copy this URL, and then you will pass this information in header, and these are your message body. So that the things. So let's close this out. So that way you can call in here. So once it's called here, it will execute. And I said earlier, add 2 into 2. So here it will return result as well. So this way it will return the result Azure OpenAI. So you have choice dot message dot content. So this is response. When you add 2 to 2, the result is 4. So that way it will return results as well. And then that return you can store in some way. So I have stored here in a blob storage, and then I'm storing into database. So you can see that here. So this is a result is storing into blob storage, and then same result you will see in a database in here as well, this one. So that way you can call Azure OpenAI, and you can return results, and you can store result in somewhere else as well. So now let's see, you can also call same thing in Postman as well. So for Postman also, you need a URL. This is same URL you need to copy from your portal. And then you need to set here headers. This is okay. And this is a body message. And then when you send this one, you will see the results as well here. And this is the result. So these are the extra parameters. You don't need to worry about it at all. You just concentrate on the so you need this element, and then you need this content, which is your response or completion from Azure OpenAI. So now let's go back here. So we have seen this demo as well. We have seen Postman, and now let's see a Python one. So for that, I have in my machine, I have Visual Studio Code, and I have a Python SDK, and I have Azure OpenAI SDK. So based on that, you can see here, this is the code. And actually, this same code you can directly copy from here in your Azure OpenAI. I think in view code, you select a Python, and then you just copy that code from here by clicking this button. So that way you copy your code, and then you go to your Visual Studio, and then you paste here in Python. And then when you run this one, it will return the result, same result which you have in your earlier. So that way you can do in your local machine. And now let's see in a notebook. So this way you can also call in notebook as well. And for that you need this library. You need OpenAI SDK. And this one I use for storing the secret in a Python environment. And here you can call your Azure OpenAI. And then you will this way you prepare your prompt. And here you will see the call. So here you are calling the Azure OpenAI, and it's returning the results in here. But it's written everything. But if you are only interested the final results, which is directly related to your problem, then you need to use this one. Dot choice, the first element, message, dot content. Then you will see the results as well here. Only one more thing important is this is your model name. So this you need to copy from here as well in a portal. Let's close this. If you see here, this code is already generated for you. So this is your model name. But if you copy it from somewhere, then you need to go to your Azure OpenAI, and then you will go to here, and then you go to model, and then you will see here your model which you have deployed earlier. Yeah, so this one is actually the name. So yeah, so let's close this out now. So that way you can call in a C# code as well. And you can run as well. I think I have recently ran, so I am not running it now, but that way it will work. So now let's go back here. Now let's see in a Fabric notebook. Same notebook you can use in a Microsoft Fabric as well. So for that, this is my Fabric notebook, and I think we are running this one. So first of all, when you copy that code in here in notebook in Microsoft Fabric, it will fail and it will give you this kind of the error that this is they don't know. So for that, you need to upgrade your OpenAI, and you also need to upgrade a PIP installation. So after that, you will see the version number, and it should be greater than a 1, because now I think recently it's upgraded, and earlier version it's not working now. So you need to do that, and then after you can run same code here, and then you will see the results. I have ran this morning, you can see that, and you will see results here. When you run this one, you will see a result as well. So that way you can do in here as well. And now let's go back to, I think we have very less time. So you can find more information here if you need. So prerequisite in order to use Azure OpenAI is you need to have Azure account, you need Azure subscription, and in that subscription, it should have enabled the Azure AI service. If you don't have that, then you need to fill up the form, which is here, and then you need to request, and you will get answer within a few days. And then also you need some right permission on your resource group or a subscription level, which you can find from here. And this one you can see if you want to apply. Earlier we have seen on public data. Now we are going to see on private data. So you have a data on your blob storage, which is knowledge, and you have Azure AI search on this data, which is a PDF file. And then user can ask a question like list of hotel in Dubai or something like that. And based on this one, AI search will return a result into Azure OpenAI, and then you will see the result in a return response as a response as well, like list of the hotel in Dubai. So you will see information from this file. So for that, let's go to here. So for that, I have this Azure OpenAI, and you can see that you have add your own data. So I have selected add your own my data, and then you can see that here. So when I ask that here, can you show me hotel in Dubai? So it gave me the results, and you can see that here reference as well, because this PDF file has a data on my private storage, and based on that is returning the result. But if I asking question that can you show me the hotel in India, so you will get this result. Why? Because there is no any information regarding India. So you can see in here blob storage. This one is a blob storage having the list of hotels information in this individual PDF file, and inside they have I think I need to download it. So this is a PDF file, and it has information regarding to hotel and links, and there are so many things, and that's only allowed to my company. So that's why it should return information from this document, not from internet or like that. So it's returning result, but you can see there is no any information regarding India, so you will not see any results, but you will see that it's not returning anything. So it will say that this information is not available. And if you want to do this, it's very easy to do. Let me remove that. You just need to add your in that blog also I have mentioned all step, but you can do it by yourself. So you need your data need to point it here, and you can see these are the different way you can do. So for example, you can use AI search as well, and you can use Azure blob storage as well. So you're selecting the blob storage because I have a file there. Then you're selecting your storage account where you have a files, and then you're selecting the container name, and you need a AI search. So you first need to create AI search instance. So I already have created, and then you need to give an index name here. That's it. So once you do that, based on that, you will see it will create it for you in here, and then you can have a chat on your data. So now let's go back to here. So we have seen this demo, and if you are new to Microsoft Fabric, then there are a trial version as well. So you can use for around 2 months in order if you want to do this demo. So for that, we are going to see quick demo. So here you can see that I have Microsoft Fabric, and inside I have Azure Data Factory. I also have Azure OpenAI, and here knowledge is internet, knowledge from internet. So for that, I need to pass this information. This is the same information we pass in a Postman as well as on a Azure Data Factory demo. So you're passing this information, and based on that, Azure OpenAI will return the results. So here I'm asking what is 2 plus 2, and it will return this result. So this is the one thing. Then another thing is I have now notebooks, and inside my notebooks, I have a data. This data is in-memory data, but it can come from OneLake or database or anywhere else. But I have used here in-memory data. So these are the list of zip code, and I'm asking, tell me about zip code. This zip code. So we are using the for each loop, and we are using the iterative way to asking each zip code, like what area it is. Is it school is good, salary is good, property price is how is that? So those kind of the question we need to know. So based on this, you will see the result as well. So this is our prompt, and this is our data, and based on that, it will return a response. So Azure OpenAI will return result like this area code is related to this city, and their property price is like this or something like that. And that is one demo, and this is another demo is missing data. So if you want to apply this on your data and find out missing data and data quality kind of things, then you have a data, private data. So this is a data I have in memory data again, but you can have in from table or OneLake or like that. And you can see that there are 2 missing value here and 1 missing value in here as well. And this is my prompt. So I'm asking that, are there any missing value in my data? Which column contain a missing value? So these 2 things we are passing, and based on that, it will returning the result. And it's saying, yes, there is a missing value, and here is a value. The purchase amount, age, and address are missing. So these things are missing. So let's go back quickly in here. So this is, first of all, we're going to see zip data 1. So this is a zip data demo. So here you can see that again, you need to install this pip and Azure OpenAI, and you need few other pandas and few other libraries. So you installing them, then you importing them, and then you checking the version numbers, and then here you will have your memory data. you can have this data from table or file, one lake somewhere, but I have in-memory data here. And then you have this is a data frame. Then here you can see that you can print your data set, which is empty at the moment, and then you calling the Azure OpenAI. You are creating object of Azure OpenAI, and then here you are creating a table, database table, dummy, temporary database table here, and then you creating table if it's not exist through this library, SQLite library, because I need to store a result into table. And then here we are going through iterative way using the for each loop. We are building a prompt here dynamically. So because we have every time we have a different zip code. So based on that, you are building here, and you are asking information regarding, population, income, and some other information related to that zip code. And then here you are calling the Azure OpenAI, and it will return a result in response. And then this is a result from Azure OpenAI in here, and you are inserting this into table in here. So you have a zip code from your original data set, and you have a description from Azure OpenAI as a completion or response of Azure OpenAI. And then if you want to see what Azure OpenAI is returning, then I have printed here last zip code. So this is the one is written from Azure OpenAI for each zip code, but here is doing for last zip code, which is this. And here you can have select from the table which we have earlier inserted, and you can save this information in OneLake as well. So I'm creating this file in OneLake, and I'm storing this information in OneLake, and you can display a result from OneLake in here. So these are the information it has stored in OneLake. So this is a zip demo, and now another demo is missing data one. So in missing data one, again, you need to install these libraries. You need to import. You're doing this, and this is my sample data, which is same data we have in a file as well. Here we are calling the function. We create a Python function, and we are calling here it, and we are building this here. So because we have a prompt and we have a data, so we are passing this one prompt with data. So we saying this is my data and this is my prompt, and give me the answer based on that. So here I'm asking that, are there any missing value or like that? So based on that, it will execute on my sample data, and it will return results here. And this is a response from Azure OpenAI, this one. So it's saying that yes, there are missing value, and it's giving the name as well, column name as well. You can do so many things, but this is a way you can do that. Here you can ask so many other questions as well, like is there any data, how distribution is correct, and data is there, or there are so many other way you can ask, and then you will see this kind of the response as well. So that is two, and now let's go back to here. So we have seen demos here as well. I think I missed one more demo, which is a data factory pipeline in Synapse. So same way you can do in here as well, in Fabric as well, not Synapse, sorry. You can call same thing here as well, which we have seen earlier, and you can return a response as well, and then you can have that in like this way. So this is a syntax for response if you from Azure OpenAI. So it's returning the response here, and you can check as well here. So this is the one is returning. I think now there is a one more. So this one demo is like if you want to do this Azure OpenAI calling in your local machine, and you can use a Streamline app, you can deploy, and you can chat like like English language, you are asking query on your data, and it return it generate this query, and then you can use this query to return results. So for that, let's go back to my local machine. So for that, you can see here that let's close this. So first of all, environment, this is the environment file we already seen. And this file we are creating here dummy database table, and we are inserting table data as well on database, local database, and this database related to finance. This is a prompt. So here we are saying that you are a assistant, and you helping to convert a natural language into a proper formatted query language. And we are saying we are providing here schema as well, and we are also saying that answer we need in a JSON format, key value pair as well here. So this is my prompt, and here I'm calling the Azure OpenAI. These are the same steps we have seen earlier as well. So we are calling Azure OpenAI, but here we are building this message. So this one is a user query, and this one is system message, which we have already in our prompt. And based on that, it will return results in here. So if I run this one, I think I already done here. So you can see that it's first of all, it will have a local URL. So let's go to there. It's here. So it will generate this, you will see in your browser like this, and then you can say, show me the data. So as it now only know the finance data because we provided the schema. So it generate this query. So this query is generated by Azure OpenAI based on this query. And then we are selecting a data. But if I say here, show me laws. So this query again generated by Azure OpenAI, and based on that we selecting results. So if you go to here and if you check here, so when first time I said show me the data, so this is my query, this is user query, and then Azure OpenAI return as this query is generate this query based on user query, English query, and then we are selecting the data from table. And then next time when I recently say that show me loss, so at that time based on the data it created this query. So this query is created by Azure OpenAI, and based on that we can see a data as well. So same way it's converting your natural language English sentence into a query on your data. So you can find more information in here. It's done by Nikhil Sehlai. So with that, I would like to thank you for attending this session, and I'm now open with a question.
Thank you so much, Alpa. That was great and very insightful into the Open AI service. Unfortunately, we've not got much time for questions. We've got a pretty tight schedule here, but again, thank you for joining us, and we really appreciate it. We're going to just pop this up for a second. We'll say goodbye to Alpa. Goodbye. Give her a round of applause.
Thank you. Bye. Thanks.
Okay, so yeah, we're going to take a quick short break now, and we'll be back in approximately 35 minutes because we're running behind schedule. But yeah, don't go anywhere. Grab lunch, have a break, and yeah, we'll be back in a second. Welcome back, everybody. We hope you had a nice lunch, and for the people attending online, we hope you had a good time as well. We hope you're feeling sufficiently refreshed. We are back now with a talk from Jonah Anderson. Jonah's going to be talking about code serverless containers and the cloud in Azure. Jonah's got a fantastic book on Azure. Highly recommend that. And we have another author coming up in a bit as well, so we can talk a bit more about people's books. But let's say hey to Jonah. I think I've got her online. Yes, we do. Hey, Jonah.
Hi everyone. Hi, Callum. I'm so happy to be
Jonah.
virtual in London today.
Yeah, thank you so
Live.
much. I saw you said that you're presenting at 3 different global Azure events in the next couple of days.
Yeah,
Today,
yes,
and then hosting
yes,
tomorrow.
yes. Yesterday I spoke in Azure User Group Manila in the Philippines. It's like a panel about Azure and cloud, and today it's a session that I am compressing in 30 minutes, so I don't eat up everyone's time. And tomorrow I'm hosting Azure User Group Sweden as well. Yeah, we have. I'm a host then.
Well, Jonah, we know you're a very, very busy person. So without further ado, let's just let you take it away. Thanks, Jonah.
Yeah, sure. So yes, hi everyone. This is Jonah Anderson, and I am presenting this talk to you from Sweden, live and virtually. And my focus in this talk is I'm going to share about coding, serverless containers, Azure container apps, and it is more focused on development. And I'm so thankful to all of you who is watching me online, virtually today, and even in person. I know maybe some friends are sitting right now watching me in live. Thank you so much for spending time. And I hope that you're enjoying Global Azure London so far. So in the next 30 minutes, I hope to share with you all the things that I want to share for today, but it is about Azure Container Apps. And I want to start about containers, because containers reminds me of the real boxes in real life. It's not just the containers that we develop on the web, but also the containers in real life. So if you see here on the left side, these are like the boxes I get when I get copies of my book for signing or for events. And then on the right side, these are the boxes that I prepare for my family before Christmas, like 3 months ahead, to send 2 containers from Sweden to the Philippines. So it reached the Philippines to my family before Christmas, and it usually takes like about 3 months before it gets there, and it's so slow. And the reason why I'm giving my talk an introduction this way, because containers on clouds, especially in serverless, reminds us that it's quicker than the manual way. And when I think about serverless as well, it reminds me of the airport queue problem that we have to deal manually when we're traveling for conferences, to events as a speaker or as an attendee, or even on vacation. Sometimes we have to deal on the airport queue problem, which reminds me also that it can be chaotic or a chaos if our applications are working that way in that queue. So if you can imagine, if we are still not on the modern way that we deal with event-driven architecture or event-driven cloud development, we will be able to experience, or we still have this frustration of waiting for each other, or waiting for the system to finish the task that we need to do, just like this image. So to me, as a developer or someone with a mix of different roles as a consultant, I take value in developer productivity. And I believe that building serverless, along with cloud native and AI solutions that we have today, very trending today, on a cloud platform, for example, Azure, enables us to build intelligent applications. And probably all of us already have a great introduction or have a great perspective technically on what cloud is, but I want to be inclusive about cloud computing in a way of explaining or showing this model. I think some of us have seen the version of this, the pizza as a service model, where cloud deployment models are being explained in the pizza way when you order pizza. But this one, the cloud computing models also describe the different typical models: the infrastructure as a service, platform as a service, the software as a service, and there's also X as a service. That includes functions as a service and containers as a service. And they are also known as the cloud computing stack. And it is a good image because it tells us, as a beginner and as a developer, our scope and which of parts of our infrastructure are we going to share or to handle. So serverless computing, it's very common. Everyone knows it. Some people think it's a cliche. It's a marketing word because it's not really serverless. There's actually servers behind it. And usually, the purpose of serverless computing is just like we as developer are given the opportunity to focus on developer productivity, focus on business logic by code, and don't or skip the hassles of management of infrastructure at the same time. So usually it's like platform as a service, and it's not just about Azure functions or functions as a service. It can be also serverless with databases, storage, and even containers and cloud native for microservices that we will be also discussing and tackling today in this talk. So serverless, we all know we are like Azure fans and learners for global Azure. We know the common ones that we have in Azure. We have the Azure functions, durable functions for the extension of it for developing and writing stateful workflows with orchestrations and all those different patterns that we have. And then there's also serverless for databases, both SQL and NoSQL type of data. And there's also the user-friendly low-code, no-code way to code serverless and workflows like the Azure Logic apps, other event-driven services. And for containers, the AKS, ACA, Azure Container Apps, and a lot more and more to come for sure in the coming future. So as an introduction to those that are new to cloud native, before I get into Azure Container Apps. So cloud native is a new thing today. Wherein it is described this way officially by the CNCF. So cloud native technologies empower organizations, even us developers, to build applications and infrastructure that are modern and dynamic. And it should be like immutable. That's why distributed, loosely coupled, and it should be easy to maintain without any effect on the production. And you should be able to like make changes to it, and it should be reliable. Automation is also one part of it, and it actually suits the cloud way that we develop applications today. Of course, we don't have to put everything in the cloud, but of course, if you choose the path of cloud native, there are actually pillars that we need to consider, or at least to know the basics. Like, for example, typically it should be in a cloud infrastructure. In Azure, it's like it's the platform as a service. It should be like a modern designs that follows actually the well-architected framework for Azure and the 12-factor application. It's actually the 12 principles that you can read about in terms of modern design. And then microservices is also ideal for cloud native. And then containers is also typical, and it should be also have the support for backing services or integration or consuming other services between applications as part of its like process. So this is a traditional monolithic architecture or app that we have in the good old days. And even now, maybe we still have that kind of system. And then there's also cloud native. So you will see that on the right side, we have this flexibility of building a micro service or like part in our application, and we can put it inside a container, and you have some kind of pub sub event bus that handles the communication between the services. And this is one of the very simple example of a cloud native architecture design, and it can be complex depending on how you build your own applications and the special use case that you have user per user of business to business. So ideal use case for cloud native, usually this one, it's either a combination of or one of the either the migrate or modernization purpose. It's typical to use cloud, especially containers, with either lift and shift or lift and shift and then modernize. So I won't get into the details of that, but I'll hop directly to what is Azure Container Apps. So Azure Container Apps, this was a quote of how Scott Guthrie, executive vice president of Microsoft, he did write this statement or explain Azure Container Apps in one of the Microsoft Build events last few years. And basically, without reading all the text, since you can read it yourself, Azure Container Apps is like serverless containers. Just like Azure Functions, you can build serverless or event-driven scenarios or fix such kind of use case, but it's in the form of containers. And to those who've been doing container development for a while, containers has its benefits in terms of like speed, microservices, and other typical use cases scenarios for this. So what can you build with Azure Container Apps? There's actually a lot of ways. Of course, number one, the common one is building containers with microservices type of like architecture or scenario. You can also, for complex scenarios, you can build it with Dapper as well. If you have a need to communicate or integrate your containers or applications between public API endpoints, typical web applications. If you have event-driven type of like scenarios, like PubSub or like event-driven type of like microservices, background processing that needs to be continuous, and also the ability to auto scale in different types of criteria that you see below. Like, for example, if you're using CADA with your services, you can use the CADA scale trigger as well for that. So this is a typical use case scenario for, I was checking my time. Okay, I think I'm still good. Okay, so this is a typical use case scenario for Azure Container Apps. Very simple one, architecture. This is an architecture diagram I borrowed from Microsoft Learn. So if you can see here, an Azure container usually needs to be like in an Azure app container environment. So it's like containers with a bigger box on top of it. So in the Azure Container Apps environment, which is the typical like group for that, you can have a container app for different type of purpose. So there's a container app example here for ingestion service. There's one for the workflow service. And that container app is connected to another apps or containers as well that handles different things. So if you can see here, it is one container app is doing the packaging service. There's one that does the drone scheduling work. And there's one that handles the delivery service. But one thing that you will notice in this 3 other container apps that the workflow service is connected to are the different types of integration it has to different types of database. So one is using Cosmos DB for Mongo API. a normal Azure Cosmos DB for NoSQL, and there's one that handles a database for cache, the Redis cache. So which actually fascinates me also, because if you have a use case that is that requires to have this distributed type or isolated way of building services without being dependent on each other, then it's really great. And as a beginner or someone that's like learning development with Azure or cloud native or containers, this is good because in my perspective, you have a lot of opportunities to learn new things and different types of databases or integration services. And of course, with container apps, Azure Container Apps, you can integrate it with services like Azure Service Bus, secure your connection strings or secrets using Azure Key Vault, and of course, your monitoring, which is also vital in terms of scaling and observability of your application to make sure that it's really working as it should be. So Dopper, I did mention that earlier, when you have complex scenarios in terms of like microservices. So as developers, we want to build microservices that follows the best practices. So Dapper, as an extension or one of the features of Azure Container Apps, actually allows us that develops containers to manage the complex scenarios of microservices because of its like different features that it allows us to do along with Azure Container Apps, like state management, input binding, the pub sub features, the secret management, and invocation of services, as you can see here. So this is good because when you build microservices or having that kind of architecture in the real world, the business use case for demand of services can increase. Like our business folks will just say, hey, Jonah, you and your team need to build another container for this one because we want it right away in production. So that would be like another service. And the more you put in more microservice in your application, the more it can get complex. And how will you do it and handle it that they talk to each other without without compromising the other features that you want your entire system to be. So I think Dapper is a great tool to check out if you're developing one. So this is a simple example that I have that I can share with you. Probably you've seen this. This is an example of a Dapper-enabled Azure Container App. So in this like simple illustration, you have an Azure container environment, the box where you have the boxes, and it has two containers. The container app that is considered like a publisher app, and then there's one that is a subscriber, a pub sub. And Dapper allows us to do sidecar. So that's one of its features. So they can do sidecar, and through pub sub and Azure Service Bus, you can enable this integration between these two applications as well. And when you're developing projects to the cloud, you actually have this like option to build with containers, with serverless, a lot of options. But one of the things that I'm really fascinated and also very interested to build with Azure Container Apps is the Azure Developer CLI. And when you start a project to the cloud, especially like a new one or even migration one, you usually need to do planning, you need to do POC, you have to deal with the team members and decide who are responsible for what tech stack we're going to use, what tools are we going to use in this project. We want to have to decide what language will we use for front end, back end, how will we do the CI/CD, the DevSecOps, infrastructure as code or not. Cloud provider, is it Azure or non-Azure provider? Are we doing multi-cloud or not? testing, automation. How are we going to do it? So these things are like the typical like things that we have to deal in our projects, regardless if you're developer or whatever role that you have as one in your IT job today. And I'm very interested to share about this because it reminds me that when we work in projects where source code is everywhere for both front end and back end, and even the DevSecOps part and integration, tools are everywhere, and it actually affects our developer productivity. And if we have a lot of tools everywhere, it means that on our normal 8-hour workday, there can be too much mini distractions. And if you're new to the project, it will be also another thing to think about. So I'm focusing right now to developer productivity because the example that I will be sharing with you is an Azure container app on Azure Developer CLI. And this is the code part of the title of my session because we were coding Azure container apps with focus on developer productivity. And in my book, I did write a chapter entirely about developer tools for Azure. And one of the studies that I highlighted is the space framework from Microsoft Research, where it is a framework that describes the different aspects of developer productivity. So we have the space. It describes our satisfaction, our performance, activity, the communication and collaboration that we have, efficiency and flow. And these are like the criterias that affect that has an impact on our developer productivity. And this is why ACD, Azure Developer CLI, which is I'm injecting into this talk as well, because it's part of my demo, tells us that we can build and collaborate with all of the things that we need in one workspace. So it's developer centric, meaning that it's more focused on the developer flow. So once you're done with your code, front end, back end, you go through the setup of your CI/CD, where you want to deploy it in Azure, and just by a few lines of command, you are able to deploy it. And it's user friendly, it's beginners friendly because it uses like a boilerplate or templates for us to get started in building things. So one of my example, for example, here is actually based on the ACD templates for PubSub, Dapper, C#, and it uses the service bus. And there's a link called awesome ACD templates that you can use. Or if you have the Azure Developer CLI like installed on your computer or VS Code as an extension, you can just like choose ACD template list to get started with your project, depending on what suits you, and then you can start from there and customizing it. But the developer workflow usually looks like this. So you just like set up everything. Let's just say we're building Azure container apps through that template for Dapper and .NET and Service Bus. So once you have set up and configured everything, you selected your template by choosing the template name, of course, you just initialize it and then code as much as you want with your team. Yeah, back end, front end, and all the CI/CD setup that you need. If you want it in dev containers or use GitHub or Azure DevOps, you can configure it up. And with these files are the important files. You code your infrastructure as code as well in there. You have the default bicep, but you also can configure it for multi-cloud option like using Terraform. And then when you're done, you just write the command ACD up, and then it deploys to Azure in a few minutes or some minutes, depending on how big it is or how many containers you have. And then if you, let's just say business wants us to add more functionality into the project or the POC, then you do your code changes and you just deploy it up again. So CLI has a different option for that locally and even locally and even in code spaces you can do that. So with the consciousness of my time and my limitation of how much time I can present, I'm gonna share with you a quick demo. Let's see, I'm just gonna show you an example of Azure. So this is one of the Azure developer CLI and Azure container apps setup that I have. So I built the container apps example using ACD. So I hope you can see the code here. So let me share first what it is. What is the architecture I'm showing? Okay. So basically the demo is about like having a checkout and order processor application in .NET. One that does the checking out, like you order something, and one that processes it, PubSub, of course, and it has this Dapper sidecar in between with the help of a service bus. So basically, in a typical, first I'll share the typical ACD, of course. So in a typical ACD project, you do have a folder called Azure. And this is where you set up your environment. So when you do the command ACD init, you can choose what environment you want to create it. So for me, I have like multiple because I was doing this like few times as a demo project. So I have like dev, I have a demo test run one, and then demos. But in the real life project, maybe this would be like dev, UAT, QA, staging, or POC, whatever you have to call it. And then you have the option to configure it up in the config.json in that folder. And then in the .NET .dev container, this is what you would need to configure if you're using Docker, for example. So this is where you set up your like Docker file and other configuration that you need. That GitHub, if you fill it up with your configuration if you're using GitHub. There's also .ADO if you want to like have a template for that and other types of way to configure the CI/CD. And then components, you do have the observability.yaml, the pubsub.yaml, and then this checkout folder is the code where we have the checkout. So it's .NET. So it uses the Dapper client, and I just have a while loop that checks that processes an order. So it's like a new object of order in a loop with 50 orders, and it's just gonna console write line and write something like, hey, this is your order number, and it's gonna like send it out to the subscriber of my application, which is the order processor, which is also another container app or another application. It is using Dapper, but what it does is that it's kind of like it uses the PubSub method for as a subscriber. So it is an Azure service or Azure Service Bus topic. It is, and what it does is that it is subscribed, so it's gonna take whatever the orders that was processed or sent out in that event for the checkout. So that's it. Azure YAML file is where you configure your Azure related configuration. As you can see here, that's the order, that's the checkout. Here is set up your language, C#, and you can also configure it up to the different type of languages that you have based on the guide and instructions, of course. And so I don't want to run it now because my time is probably limited, but I do have a prepared like I do have a prepared Azure portal where I already have deployed this one. So let me just see if I could show it to you. So maybe we have time for questions before my time is up. Let's see. Okay. So let's see. So this is one of the environments. So you remember I had like several environments in my VS Code. So here on top, on the Azure config, I have like one of my environments is demo test run one. So I had deployed it when I did the commands ACD up and deploy this Azure Container Apps through ACD. So it did that with all the infrastructure build, with Bicep and all of that. So it did create the container app for checkout and orders. And it is within the Azure Container Apps environments that you see here. And with that, it also has the container registry on Azure. When I was developing this locally, if I had time, I could have showed you. I was using Docker desktop locally to work or to look or debug what's going on with my container application locally if I want to test it before I do my ACD up and deploy it in a few minutes to Azure with like iteration of changes. So you can there's this service bus that you could see. So you won't be able to see activity because I did not run it. But the last time I ran it was like a few weeks ago. So you will be able to see that here as well. So that's my demo. Let me just go back to my other parts of the presentation so I can maybe take questions. So there is a link. Actually, this QR code will allow you to learn Microsoft like Azure Container Apps, how to do this example through this QR code. So there is actually a learning path for this, and I recommend you to check out Azure Developer CLI and its awesome templates, because it has a lot of things that will enable you to learn new things, especially when developing with Azure, not just Azure Container Apps. So you have so much to learn. I also have a lot actually to learn as well. So and I have so much to share, but check out my book if you want. I did write about a lot of things about cloud native and Azure Developer CLI as well. And to those that wants to read my book, maybe have seen it and wants to check it out, I'm actually giving away like 30-day access to the Learning Microsoft Azure online book. So all you need to do is go to bit.ly Learning Azure book. You sign up using the code Azure23. That's special for my book, 30 days. And then you scan the QR code, you will be able to read my book virtually. So, and if you have questions or feedback or even errors or errata, feel free to share it with me as well. Learn more about Azure Container Apps and how to build it with Dapper using the QR code AKA/MS/ is ACA-Dapper. And I know that there's like an active community call for both ACA Azure Container Apps like team and also Dapper community if you want to get involved in contributing your own templates to this communities as well. So learning path, there's so much. Maybe this week we are so overwhelmed with lots of global Azure content, but when you have time, try to go through the learning path for Azure Container Apps, because I believe containerization is also one of the things that's going to be trending aside from AI this coming days. So learn and have fun. Enjoy Global Azure. It's a global event. I'm excited to host our event also in Azure User Group Sweden, and have fun like my dog Lawrence, who's been enjoying the last part of snow that we have here in Sweden, since it's not summer here yet for us. So thank you so much, and I'm ready to take questions if there's any, and if I have time.
Thanks, Jonah. We're giving you a round of applause here. I don't know. Is there any questions from the room before we move on? No, doesn't look like it. But thank you so much,
Okay.
Jonah. It's great to see you here and for giving us your time. And I'm sure we'll see you around somewhere soon.
Yeah, I hope to join in person next time.
Of course, yeah.
All right.
Hopefully.
Thank you.
Okay. So we're going to a short break now, but we'll be back in a little while. Don't go anywhere, please.
idea of how well I'm
Hey everybody, if you could take your seats, we're going to get started again. We are back at Global Azure London here with a fantastic talk coming up from Simon Painter about would you survive the Titanic with ML and .NET. Let's give Simon a round of applause.
Let's see if that round of applause survives the end of this talk. Is everyone all right? Yeah. I said, is everyone all right?
Yes.
Okay, let's have some fun. So I'm hoping that everyone has at least heard of the Titanic. If not, I'm pretty sure it's the place where Kate Winslet killed Leonardo DiCaprio or something. It was a big boat what sank over 100 years ago. But, right, okay, let's get going. First off, I am the author of this book here. I have some copies about my person. This link, incidentally, is something O'Reilly provided me. If anyone's interested, it'll give you about 30 days on the platform. I think that Jonah may have already given something similar, but if you didn't catch that one, go ahead and catch this one. I can bring this slide back up later if you like. You can read what books you like, but, you know, maybe you'd like to read this one. It's quite nice. I spent a lot of time on it. It's very silly. What is machine learning? First, let me be clear, because there is some lack of clarity in some people about what is the difference between AI and ML. So, to be clear, all ML is AI, but not all AI is ML. All good? So, machine learning is a subset of AI, specifically dealing with things like crunching data and trying to make decisions. There is a subset of ML called deep learning. I am not doing that. If you want to know what ML really is, it's statistics. Really and truly, that's what it is. It's mathematical statistics. You can learn most of the techniques that are used in modern machine learning by picking up any given textbook on statistics and working your way through it, because that's roughly what it is, except applied by a machine that does not get bored nor require coffee as I do on a regular basis. So this, incidentally, is a very good book, and I do recommend this book. I enjoyed it a lot, but then I am a nerd, and I enjoy mathematics, because I do. And I have been trying to learn ML. It's something we're very interested in at the way so I work, which is Muller. Has everyone heard of Muller? Muller as in corner. If you have drunk, sorry?
No, Muller coffee.
Muller coffee? No.
That's mocha. Sorry.
Oh, no. Muller Corner, the rather lovely yogurts with a bit of chocolate in the corner. Or if you have ever drunk milk in the UK, I can almost guarantee you that that was us, because we supply milk to pretty much every supermarket in the country. If anybody ever wants to tell you that Waitrose milk is better than Tesco's, it is not. It is the same stuff. I know, because I've seen them do it. Okay, so we have some interesting ideas about what we can do with ML, and one amongst them is things like trying to predict how much cream will be yielded from cows given the year and the weather, because that's a thing. That is a thing. So I've been trying to learn AI, and this is the website I've been doing it on. This site is called Kaggle. If anyone is interested in machine learning and data science, this is absolutely the place you need to be going. This is Kaggle. It is literally a learning site for ML. It has many challenges and tutorials and so on. This is a great place to get started. And there is one particular challenge, which is sometimes referred to as the hello world of machine learning, and that is the Titanic challenge. So why the Titanic? Other than it being made into a film in the 1990s, which honestly I didn't like. I mean, I already knew I was going to end. Spoil it, the ship sinks. But why the Titanic? So first off, it's got a lot of interesting data problems in it. And effectively, you can boil everything down to a simple binary choice at the end. True or false, did the person survive the Titanic? That is the challenge. You have got a passenger manifest of the Titanic with a set of data about each person traveling on the boat. And then at the end, you've got to make your algorithm make the choice. Did that person survive or not? And the challenge is to get as close to 100% as possible. Now, I haven't had the time to really go into this because I have seen some of the ways that people have solved this problem. And honestly, they get ridiculous and cool and a little beyond me at the moment. But I'm getting there. So I have just at least tried to make a start by having a go with ML.net, which is what this talk is going to be about, which at least will get you some vaguely reasonable results with relatively little effort. Okay, here are your data types. for assessing survival, true or false. In the training data set, because we have partitioned the data away into sort of 2/3 of the data and 1/3, the 2/3 has got the survived yes or no filled in. The test set, the real set, the challenge set has that bit blank. You have to fill it in. That's the challenge. So it is a 0 or a 1. P class, that is passenger class. What class of ticket did they get? First class, second class, third class? Because strangely enough, that did make a difference. 'Twas always thus. Sex, male and female. This is data from less enlightened times. I am aware there are more answers to this question than 2. This is from 1912 or whatever it was. Back then, they weren't wise enough to know that there was more. But for the purposes of this exercise, there are 2, okay? This is me making no comment myself whatsoever on the people of that time. Age, well, okay, that's easy. Number of siblings and spouses. I don't know why they're groups, but they are. Number of parents and children. The ticket number weirdly makes a difference. I don't know, but it does. The fare, how much you paid. Yeah, again, does make a difference. Cabin number, interesting. Come back to that. Port of embarkation, because it turns out, I didn't know this, they didn't show this in the film. The film lied. The Titanic made a couple of stops on the way to pick up more passengers. They stopped at Cherbourg, Queenstown and Southampton. Okay, I didn't know that. Right, let's have a look. First demo. I've done a live demo before. Has everyone made the proper tributes to the demo gods? I hope so. So first off, I'm going to start in VS Code, because VS Code is one of the very best places to do this sort of thing. VS Code is fantastic because it supports...
Zoom in.
Yeah, sure thing. Zoom in. Yep. Will it zoom? Will it zoom? Will it zoom? Really? You want zoom? You want zoom? Proper Visual Studio or Zoom? Don't worry, I'm not going to be spending very long here. Okay, so I have started with something called a Jupyter Notebook. Apologies that it's a little small. Turns out that this doesn't really view. We've got a zoom.
Control plus, I think.
Control plus. Control shift, full stop.
Control shift and full stop. Nope. Anyway, sorry, let's move on. Time is limited. So, Visual Studio Code, I'm doing a Jupyter Notebook. So Jupyter Notebooks are actually written in Python. But Jupyter Notebooks are a fantastic way of just throwing some ideas together and trying a whole load of stuff, because there is a little bit of an impression, particularly amongst the senior management of my business, that ML is just kind of like, here's my bucket of data, boom, answers come out. No, it's not that easy. Really and truly, what you need to do is to be able to eyeball the solution. That is, you have to be able to see it with your eyes to some extent. Maybe you can't make the fine distinction of like this zone to this zone, but it's still necessary to kind of see it. So it is worth using something like a Jupyter Notebook to just try and blast through the data, try a lot of ideas out until you start to see something emerging from the data. Then we can start codifying it away into something like .NET, where it's a little more expensive to try out ideas. So this, as it happens, is just quickly open up the thing. Is it going to, come on, is it going to work? Install kernel. Really? Really?
Kernel.
Really? Oh, that's rubbish. I mean, I literally ran this last night and I had a kernel then. Have we got... It's forgotten. Right. Okay, well, let's give that a minute. Anyway, all this was going to do was going to put a describe here. All I've done is read the data in. I'm using something called Pandas, which is a tool for kind of like processing data and moving it around, reshaping it, putting diagrams from it, that sort of thing. Pandas, and then describe, which would have given me things like mean, median. Thank you, virus scanner. It's lovely to see you. Oh, you must go away. Not working? No, let's try it. Come on, run. Really? Okay, fine. I literally ran this last night and it was happy as Larry. Oh well, it's not going to cooperate. Fine, I'll talk through what I was going to do. But what I've been able to do here is, unfortunately, I can't zoom it. I've done things like read the data in, and I've gone through each of the data points to try and clarify and cleanse it a little bit. I've done things like tried to make everything numeric, because what I was hoping to be able to show you was a flipping nice, which there is a copy on my slides. You can make a heat map. You could use some of these tools in this to make a heat map. The code for it, but oh, look at that, it's still open. Marvelous, great. Okay, I've got something. Right, so what I did was I tried to cleanse the data. That is, to make things work in ML, everything really has to be a number. And if it's not a number, you've got to make it a number. So sex, for example, that's one of the classic examples. There are only so many answers. Yes, there are more than 2, but there are still only so many. And you can arbitrarily assign a number to each of those. For example, male equals 1, female equals 2. That does not imply superiority of one over the other. You're merely assigning a number. And if you've assigned it a number, that means that ML can treat it as a number. You can treat it as a categorical data, but in numerical form. I think that the usual algorithms of one hot encoding, if you want to look that sort of thing up. And I've also used a couple of other tools here, having sort of cleansed my data, turned everything into easy categorical numbers, using PyPlot and Seaborn and a few other things to make some charts, which is where I can start to see some of the patterns in my data. This one, for example, is age, and they're going along the side, the bottom there, total family, and the colors represent survived or not. Yellow is survived, blue is not. But you can sort of see there is a sort of a pattern emerging there. There's a sort of block in the middle where we don't have an awful lot surviving. There's a lot of stuff on either edge where we got a lot. So people who are very young with few family or very old with few family seem to be more likely to survive, stuff like that. But if we can see some vague pattern there, that might be something we can feed into the algorithm to understand. Oh, this one here. This is a D plot. So this is age and survived. That's it. This is just how many of each age survived. The orange line is that they survived, the count of how many survived at each age. The blue of not. And you can see there is a variance. There's a couple of weird little blobs where there's extra bits that the survived is looping up and back down again, or not quite peaking as high. So there's clearly something there to age and survival rates. Now, that's pretty dramatic here. This is a count plot. So this one is based just purely on class. This is the class of your ticket. Did you have a first class, a second class, or a third class ticket? Well, look at this. Orange means you survived, blue that you didn't. First class, majority survived. How about that? Second class, about ease 50-50. Third class, ha-ha! You might as well pray. Because those guys are down at the bottom of the boat, according to the documentary that I saw in the 90s with like goats and people playing Irish folk music. And no, I don't think it was like that, as much as James Cameron might have liked to believe it. But you get the idea. They are down the bottom of the boat where it's a lot harder to get to the top, where all your rich people at the top have probably already nicked all of the lifeboats. Again, 'twas always thus. This is a plot of family, simply count of family. So we've got a little bit of a variance there with survival rates. As you get more family to an extent, looks like you've got a better chance of survival. So count of family looks like it's a good one. And this finally is our heat map. So there is a concept of correlation in data science, and this is a map of how much do this column and this column correlate with each other. This is graded between -1 and 1. 0 means they have nothing to do with each other. They might as well be random. -1 means they correlate perfectly, but in an inverse proportion. That is, as one goes up, the other down. And 1 means they correlate perfectly. That does not mean they have the same values, but it means as one goes up proportionally, so does the other. The closer to 1 or -1, the more statistically significant it is, and the more worthwhile it is for us to pursue it. The red line down the middle is the data point mapped against itself. It is irrelevant, but, you know, pretty. In fact, our highest rate on looking at this is 54%, which we have as a correlation of survived to sex, that is male or female, because the rule of the sea, women and children first. It turns out it was largely true on the Titanic. The women have a massively more higher rate of survival compared to men. There is a -55% correlation between fair and class, which is true but irrelevant. What that means is as your class of ticket goes up, so your fare comes down or something like that. Basically, you're paying more for a better class. So yeah, okay, fair enough. We've just proved it. Better tickets are more expensive. But what else have we got to correlate against survival? We've got passenger class -34%, still significant. Age 0.077, not terribly significant. Ticket 0.06. So, but the best ones are fair. That is how much you paid for your ticket, and what is your gender? Possibly also where did you embark with -13%. So that's all very interesting. Let's move on. Slide. Okay. So moving into ML.NET. This is a range of technologies available from Microsoft. ML.NET, the one I'm going to be looking at, is not so much a native Azure version. I will touch on the native Azure version. It does exist. But ML.NET is something which you can install in Visual Studio. You literally just go in and it's an extension. It's a Visual Studio extension you can install, and there it is. It's almost there like a new file type. The same as you might right-click, and we're running short on time, so I'm not going to demonstrate that. Okay. In fact, I might just skip making an ML context because we are down to 15 minutes now. So, but you literally just go right-click, add, and then instead of file, class, whatever, you will find ML context is there. And there's just a wizard that you go to and then press finish and bang, the code is in there. I'll show you how it's working in a minute. So this is this is a screen grab of the describe. So a couple of things that we can look at here that might be worth having a mess with. So you count how many data items. Age has only 714, whereas everything else has 891. Okay, the reason for that is that a whole load of ages are missing. So if we want to make this interesting, what we're going to have to do is fill in the missing ages. There's also, and here is a look at the data itself. Now it's a little small, but don't worry, I shall annotate. So there's passenger ID, which is literally an ID number. This is irrelevant and of no interest. Class is numeric, that's fine. We've got name. There's not really a lot ML-wise we can do with that at the moment, or is there? Sex, male, female, fine, done. Age, they're missing. Now, what could we use to fill in the missing ages to try and get better results? Well, there's a few things. How many family are you traveling with? If you're traveling with more family, more likely that you're going to be younger and vice versa. But also, if you have a look in name, it's got the titles. It's got everyone's title. Mr., Mrs., Miss, Mademoiselle, there is one of those, and so on. We can probably make a fairly educated guess at someone's rough age based on what title they have and how many family they're. So we can use that. The cabin number is and isn't relevant. If it's got numbers like C2123, E46, now I think it should be on the next slide. This is a plan of the Titanic. Deck A is at the top, deck G is at the bottom. The first letter of the cabin number tells you how far down the ship you are. That is useful and relevant. It's not a number, but we can extract that first letter and then turn it into a number, and then suddenly it's data and we can use it. Embarked is similarly categorical data, so that's easy to use. Okay, and yeah, I've shown you through that. There we go. So what else? Well, which elements are specifically useful for survived? Well, we've got passenger class, sex, fare. Those are the ones I want to focus on, and maybe embarked. So let's focus on them. Put it all together. We are down to 17 minutes, so let's have a look at the code. Here, incidentally, is my final end result. Here, there we go. This is what it looks like. You've got a whole load of scenarios that you can choose from here. I've gone with data classification. Data classification is, do you go to this category or this category? This is categorical data. You can go for value prediction. That's what I use for defining the ages. And that is, we have a range of continuous values, like age, which starts at 0 and ends at theoretically around 120. Recommendation, forecasting, image recognition, all sorts of other things. I haven't done any of those. Right, you tell it which environment. Well, I'm going local for the time being. And then you feed it the data. I fed it a CSV file. You can also go to advanced data options here, which gives you the ability to ignore, which I've done for, say, something like title and passenger ID, because title was useful for filling in the missing age value, but not useful for calculating survival because we already know the age at this point. So what's the point? You can also define one of several data types. We've got Boolean, string, single, and date time. Those are the only ones you can use. Single for numeric. It's effectively, it's a float. Those of us working in .NET will probably know it better as float. Boolean, well, I hope you know what that is. Otherwise, what are you here for? And string and date time. So that's it. Those are the data types you're allowed. And then you go to the train. Okay, that's not going to work, is it? Turns out, I don't know why that's not work. File. The base CSV is missing. Okay, fine. Maybe I can just quickly tell it where it is. So that's train age 15. That's something I can do. Right, let's quickly look through this. I was hoping to be able to show this running. Wait, let's look at version 2. So very quickly, what I did, because we're almost out of time now, I went and used Sylvan to extract all the data from a CSV, parse it into the correct form, and I cleansed it, which is, where is it? Generate cleansed data, there we go. So I did things like I split out the title from the name. They're all in the format surname, title, first names, and extracted them out. I simplified all of the rare names. This is a technique I picked up off Kaggle from looking at the chat. There's no point. I mean, there's one called Yonkher. Now that's very interesting, but not useful. So you may as well just simplify all of those to a simple value rare, because there's only one of them. There's only probably one major, and there's a couple of countesses on board. So there we go. I simplified siblings and parents into family count, which is more useful statistically. The cabin letter has been extracted from cabin. Their embarked has been simplified, and ticket, I've extracted out simply the number from the ticket and removed all of the extraneous additional characters. And that gives me my cleansed data. This is all pure.NET at this point. And then I used an age predictor, which is one of those, and this is how you do it. This is how you actually use ML.NET right here. I can blow that up a bit. There we go. This is predicting an age. So by running that, it's kind of like database first EF in a way. You're feeding it the database, and you're getting back a whole cluster of objects which are available to you. They're static objects in this case, age predictor, which is what I called it, .predict, and then feed it a new model input, which is based on the CSV file that I gave it as raw data. And then that will give you a score, which actually comes back in float format. I want it in decimal because I prefer decimal. But that is its prediction on what the age of everybody looks like. Hopefully I've got a data cleansed here. Going to open. There we go. Can I blow that up? Oh no, that's not it. Train refine. It was in here. It was. It says train age filled in. There it is. There you go. Look at that. So we've got this Mr. whoever he was. It doesn't matter because his name's been removed by this point. But he was a Mr. He was traveling without family. It's predicted he was 28 or 28.565. That's very specific, but there you go. That's what happens when you're predicting numeric data. This Mr. and Mrs. 30, 34, not unreasonable. Have we got any low ones? 45, this one. I don't know why, but there we go. I fed it all the data, and this is what it predicted. It's probably used, this one is a master. It's predicted them to be 5, which is not totally unreasonable. It could well be. Now, I've compared these against the real answers. Some of them are pretty good and pretty close. Some of them are a little off. But broadly, it's still good enough. It's good enough that we can put this into the final result, and you're getting something closer than using 0 as age, because 0 as age is telling you actually the wrong thing. This is implying that you've got a baby when it's not. You want to at least, even if it's not right, it's still good enough to make a more educated guess than what you would otherwise be using. So that's why we're predicting the age. And then, there we go. I've also filled in, there were a couple of missing embarked. So what I did there was get all of the embarked values, work out which is the mode. The mode is the most common value, and then I use that as a replacement. The other thing you could do in some of these cases is take an average age and then just fill in with average age, which is still better than 0. And then feed all of this into a predictor. How are we doing? 23 minutes, we're doing all right. There we go. This is a predictor when we are predicting categorical data. So in my case, it's true or false. It's a Boolean. And it's the same basic idea. I've called it Titanic Auto 3 because it's the third version I'd made. And you're going to create a new instance of the whatever you model input. Instantiate all of that. So I've given it class, sex, age, family, fare, embarked, cabin letter, and ticket. And all of those have come from CSV data. And I want it to make a prediction of what the answer is in terms of, there we go, and it's got a predicted label. Now, it's actually predicting one of a set of numeric labels. It's going to be 0, 1, 2, 3, like that. As it happens, I've only ever given it 0, 1, so it will only predict 0 or 1. If there were more categories, then it would go beyond 1. So I'm basically treating a numerical categorical data as a Boolean, which is good enough for the purposes of what I'm doing here. It's not going to randomly throw in a 2 because there were no 2s. And then it's throwing all of that into an array. and then bang, we get our answer. Now, I've actually gone and nobbled a copy of the answers, which I got from somewhere, and so that I can run local tests rather than, because you only get 10 tries a day on Kaggle itself. And with all of that, I get 76.6% accurate, which I've seen people do a lot better. I've seen people go above 80% and above 90% and so on. But what this is doing, when you do this this automated thing, if you give it loads of time to train, it's actually trying something like 70 different machine learning algorithms on the same data, rating each one based on how well did it do against the training data, and then giving you the best one. It's trying tons of stuff. I gave it 200 seconds to run. And in all of that time, it was constantly pushing the same data through different algorithms and trying loads of different options. Now, doesn't mean that I'm going to get the absolute best result ever that's possible in the world, because you still have to do data cleansing. There's a lot more I could do with this in terms of things like processing all of the data to make it easier for the computer to make a prediction. But nevertheless, that's still pretty good for the amount of effort that I put into this. 76.6% isn't terrible. I have seen far worse results in professional machine learning tools. But with a whole load more time, I could probably massage the data yet further, get more out of this. And that would just be messing around in .NET. That's not doing complicated machine learning stuff. That's just going to be like looking at the data and trying to create more sort of pseudo properties from my data. Maybe I could have a look at which corridor they were down. Maybe there are also ways of sort of massaging the values so that that outliers become more extreme in different directions and you get better results from your algorithm. So what I would like very much to finish on is to have a quick go at this. And I don't know if it's gonna, it needs train age filled in. Let's see if I can make it work. Age filled in. Well, come on. I want to actually see it work. Train age filled in. There it is. I don't know why it couldn't find it, but there we go. Is it going to work? Are we going to work? Okay, advanced data options. Let's see if I can do this quickly. Passenger, we're going to ignore. Survived is a feature. Oh, yeah, that's a feature. That's made them all feature. Yeah. It's a label. Okay, that's a single. It's categorical. P class is a feature. It is a single. It is categorical. Title is a feature and string. Yeah. Sex feature string. A should be string. Yeah, it can be string. And that's categorical. Age is a single. It's not categorical. Family is single. That's fine. It is single. Is single. Cabin letter is should be categorical, and embarked should be there. That should do. Next step. I don't have all that much time, so I'm just going to give it 20 seconds. And I'm going to train it again. May not get optimum results, but still, nevertheless. You may or may not be able to see down the bottom there, but it's listing the different algorithms that it's trying out. Fast Forest OVA, Light, GBM Multi, Fast Tree OVA. It's trying a whole load of different algorithms out. Because I've only given it 20 seconds, it's only trying 5. I normally give it about 60, 70 algorithms to try out. And we're going to finalize the model. And then what I will do is I will ask for a volunteer to see whether you would survive the Titanic, because it should. There we go. Next step. Let's try it. Who wants to volunteer to find out if you would survive the Titanic? Madam, if you would not mind, your class 1, 2, or 3. Where do you think you fancy sitting in our virtual ride in the Titanic? Do not worry, this is entirely virtual. You will be safe.
One and only, so yeah.
Yeah, okie dokie. Title, if I may be so bold, Mrs. Miss, Mr. I don't make judgments.
Oh, but it's a possibility only to choose one of the two, isn't it?
Yeah, Mr. or Mrs. would be ideal. Okay. I don't judge. I'm assuming female. Is that all right? Age, if you don't, you could lie if you wish. It doesn't really matter.
Yes, let's do that. 18 again.
Okay, why not? Why not? Family. How many members of your family are you traveling with on board the ship today?
Well, if I'm 18, probably alone.
Okay, 0 it is. I'm just going to leave ticket number. Fare £71. Sound good to you? That's pretty reasonable. I'll leave that alone. Cabin letter. I'll leave those at C. It's said that you embarked. You're in row C, in what do you call floor C. So that's only a couple down from the top. That's a nice view from there, I think. And you embarked C. So let's see. Predict. Did you survive?
Was that pre-populated data random?
Yes, it was. You survived. You have a 95% probability of survival and a 5% probability of not. So that's pretty good. I don't know if I could tempt you to copy my book as a thank you. The C# book, if that's of interest to you. I'll come along and pick it up in a second. Okay, now we have 1 minute left. Does anybody have, yeah, please. Does anybody have any questions at this time? Yeah, I saw that hand up first, so, sir. You may have to speak a little loud, my hearing is not good.
In machine learning models, you tend to run into problems around overfitting.
Overfitting, yes. Machine learning algorithms can run into problems overfitting. Yes, this is where you've overtrained it and it's too hyper-specific on the source data, and it doesn't apply well subsequently.
Specific to ML.net, is there anything to sort of protect or help you with that, or is it still you as the user or the trainer to?
Specific to ML.net, is there any way to protect against overfitting? As far as I'm aware, there's nothing specific. Now, we're running out of time, but I will just very quickly shove on. There we go. I don't know if you can see that, but this is another option that you've got. So this is like the grown-ups version. If you don't want to use the automated method, you can create something called an ML context, and you can start specifying for yourself which algorithms, how long to train, blah, blah, blah. But this is still requiring your expertise. So if you want to do something more complicated than just sort of take some data and spit out an algorithm, a result, this is an option for you, but you've still got to know for yourself that this is what you've got. So you can hand code them. Again, not a million miles away from the concept of EF. You can write your own context or you can go automatic. That is it. I'm afraid there's no. So would you like a C# book? Right, so this is yours. I'll hand you over in a second. Also, just very briefly, there is an ML Machine Learning Studio. It's on ML. It's called ML Machine Learning Studio, and it's pretty much the same sort of idea of what I've given you. You can actually either give it a Jupyter notebook and have the Jupyter notebook run in the cloud. You just have to specify a GPU and stuff like that to make it work, and or you can go more complicated and start feeding it data, and it will even process the data and then give you a machine learning tool back, and it will even automatically generate a web service which you can then use to get your results via web call, not unlike an Azure function.
What will be the difference in performance if you execute the same code in MLNet or just in Azure Studio?
What would be the difference in performance between?
Will be one quicker than the other, or
okay,
is it the same, or is just different?
Okay, so the difference in performance between doing it in Visual Studio versus doing it on Azure, I don't know, but I suspect that'll be largely down to how much money you've spent on the Azure thing, because you have to specify which sort of processor you want to run in the cloud, how much processor time you want, how big a process, blah, 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 whether you want it to have a GPU attached or not. So the more money you spend, I would imagine, the faster and the better results you're going to get. But if you're in Visual Studio, then it runs at whatever speed Visual Studio runs at. Once you've actually compiled the results, I mean, the slow bit is actually getting the actual context working in the first place. Once that's done, getting results is actually really quick. It's just that it's the training that takes the time. But you're not going to do that every time, of course. The training is a one-time only operation, probably, unless you want to schedule it or something like that. So, but there isn't.
So just to add a little bit onto that, because I work a lot with Azure Machine Learning Studio, is absolutely correct. It's the training part. So with all generative AI models and everything at the moment, training being done in the cloud seems to be a pattern, because obviously dealing with larger models, larger data sets, stuff like that, it's an optimized way to be able to do it rather than having to do anything locally and having the power to do so. But as you said, once you've actually trained that model, all you've got is a mathematical equation at the end of the day, and it just puts the data in, does the sum, and then puts more data out in some senses. So the inference part, I don't know what the benchmarks are, but technically something like ML.net, where it's on, say, a local device, should technically be quicker, because calling off to Azure would have some form of latency associated with it. But yeah, training definitely in Azure. Ease of use, it is a hosted service and stuff like that. Having that in Azure is a possibility. It's just an API call away, as is a cognitive services, for example.
So I just summarise that very briefly for the microphone.
Yeah, sorry.
But so it sounds like training in Azure is a really good idea because it can handle that sort of volume of data. And just shake your head if I'm summarising wrong. But running locally may be faster because there is an inherent loss of time because of the round trip of bound to Azure and back again. Whereas running locally is going to be really fast because what this is spitting out at the end of the day, it's not exactly it depends what you've done, but it's often not quite an equation, but something like it. If it's a decision tree, it'll be more complicated, but it's still roughly like running an equation, so it's fast. It's the training bit that's the tricky bit. Okay. So anyway, I think we're out of time, so thank you very much.
Cool. Thank you very much, Simon. I don't know. There we go. Sorry, Dan.
No, it's cool.
Do you want to do that introduction
Yeah,
once
yeah,
more?
it's cool, yeah.
Very sorry.
Yeah. Oh, again. Cool. Yeah, my name's Dan Lister. I'm from sunny Manchester, and I'm here to talk to you about Umbraco Cloud and the journey that we've been on over the past kind of 2.5 years, our transformation journey on one of our products we've got. So yeah, I'm a staff engineer on the cloud platform team at Umbraco. Started working there about 3 years ago, and I've been using Umbraco since about 2010. That's my little social thing on LinkedIn and Twitter and all various places if you want to like and follow and stuff like that. So yeah, I'm going to talk to you about what we've done over the past 2.5 years. So it's mostly a story. We're going to dive into things like how we use Kubernetes, how we use API management, and also things like how we use Terraform, how we use Azure DevOps, and something we call platform as a service. And then just some other stuff about the product and what's coming next. So I thought it'd be cool just to give you some background about what we do first before I actually carry on with the stuff. So has anyone used Umbraco before or heard of it? That's cool. Has anyone used Umbraco Cloud before? Cool. Okay, so for anyone that's not familiar with Umbraco, Umbraco is an open source content management system. It's completely free. It's built on .NET, and I'm biased, but it's super cool. You can do so many different things with it. You can use so many different front-end frameworks, back-end languages and whatnot. There's a really great community that we've got with Umbraco, and you can integrate it with loads of different third-party tools and products and stuff like that. And one of the offerings we've got as a company, we've got something called Umbraco Cloud, which is like a hosted version of Umbraco. It's a software as a service, and it's a great place where you can host your Umbraco projects. And this is just an example of what it looks like. This is our fancy new UI, which we released yesterday. It's kind of cool. So in this, we've got like 2 environments. You can create new environments to click of a button, stuff like that. You can create deployments, you can do upgrades, all sorts of cool things. And this is the product that I work on, along with lots of other people. Yeah. So with Umbraco Cloud, you get loads of cool stuff. A couple of my favorite things are, let's have a look. What shall I choose? Oh, single sign-on. So say if you've got like multiple websites from multiple different customers, you can have one set of credentials for all your different websites. It's really cool. And then you've got other things like an Umbraco Cloud API, which we released a couple of months ago. Automatic upgrades just to make sure your Umbraco instances are fully up to date. And for some of the statistics that we've got around 7,000 or just over 7,000 different environments that we have in Umbraco Cloud. And on average, every 7 days, we handle 7 billion requests to various different things, which kind of translates into 60 terabytes worth of data every seven days, and around 125 million page views every 7 days, which is kind of nice. In Umbraco Cloud, you can create projects in 4 different regions. So we've got the Netherlands, US, the UK, and Australia. So it's quite nice in terms of where you want to host your Umbraco projects. And Umbraco Cloud is built up of 3 things. So we've got the portal. It's kind of the management side of things where you can manage all your projects, you can manage your websites, and you can log in and do stuff. You can create new projects. We've got the websites kind of thing. This is where we host all our websites in Azure using Azure App Services. And then the third part, which makes up Umbraco Cloud, are the services. Now these are all like the background services, the .NET applications that we've got. And I thought it'd be cool if I just explain. I thought it'd be cool if I talked about the journey we've been on to re-platform our services in Umbraco Cloud. The websites and the portal, Azure App Services, SQL databases, we've got a lot of them, and the services manage all of those. So I thought I'd start with a little story. 2.5 years ago, my team lead messaged me saying, we have some business requirements and we need to host Umbraco Cloud projects in different regions. Now, prior to this, you could only create new projects in one region, and that was Netherlands, West Europe. But we wanted to give our customers the flexibility to host Umbraco Cloud projects in different regions. So Martin, my team lead, asked me to do this. Well, us to do this, not just me. And I thought, yep, that sounds really cool. And he also wanted to re-architect the way we host our background services at the same time. And that's even better. What's more exciting than a re-platform and a chance to do something new and something cool? So Martin then started to tell me what he wanted. So he wanted high availability, he wanted scalability, he wanted to be able to host stuff in multiple regions, and he wanted the ability to create and deploy our things into new regions like super quick. And we also needed another way, or a more modern way, to host our kind of background services, our .NET applications. And I was a little excited, along with everyone else in the team. So we set out on the journey. For a couple of months, we came up with some proof of concepts, and I just thought I'd explain about what we started with. So before we did the proof of concepts, we started with one virtual machine, which had around 26 different Docker containers on that one virtual machine. Each one had its own port number, and all of those containers were accessible through private IP address within our internal network on Azure. And the Cloud Portal, what I mentioned before, was able to access those services via the private IP address and port number to do what it needs to do. So, for example, a customer could go to the Cloud Portal and say, hey, I want a new website, or I want to upgrade this website, I want to do deployment. It would use this private network connection in order to do so, to make our services do stuff. So that's what we needed to change. We wanted to re-platform stuff, we wanted to make things better. So we looked at a couple of things to start with. And the first one, or the first idea we had, was to basically just have multiple machines in multiple different regions. And that brought kind of complications. So we had to do things like network peering, private DNS zones, just to make things accessible and easy to read. And then we also looked at something called Console, which I can't quite remember what it does. I think it's like some sort of service discoverability thing. And we did all this. We kind of got something working. It looked like this. And we were kind of like, what the hell? This is far too complicated. Like, surely there's a better way to do all this stuff. Surely there's an easier way we can manage things better. So we thought, let's take a different approach. So the next kind of proof of concept we did was Kubernetes. That was kind of the first thing that came into our head. We'd had some experience with it before. We played around with it. We'd done our own proof of concepts and whatnot. So we asked ourselves why. Not just because it's cool, and it sounds cool. Kubernetes is like a trusted orchestration platform. It's part of the Cloud Native Computing Foundation group organization, and it's really great at like hosting stuff, especially complex applications. It's supposed to make it easier. Most of the time it does. But we found it was a good kind of candidate for what we wanted to do. Fortunately, Azure have AKS, or AKS Kubernetes services. Now, this is a hosted version of Kubernetes. We did look at other things like Azure Container Apps and Azure App Services, but things like Container Apps were still in preview when we looked at it. So we chose AKS at the end of it. And one of the things we wanted to try and do was get rid of those static IP addresses and port numbers as well, by answering this question. And in our travels around the Azure landscape, we found something else called Azure API Management. And again, same with Kubernetes and AKS, we'd had some experience with it. We thought it could work, and we tried to make it work and make a proof of concept and stuff like that. So that's what we did. And this is what we did. The first stop was Kubernetes. So the first task we had was to make a cluster. This is our cluster in one region. I think at the time we had like 26 different services, and the services were built up of two .NET applications. One was an API, one was a worker. So the first challenge we tried to accomplish was to just deploy that to Kubernetes, see if it ran, see if it got any errors, stuff like that. So we did that. We had an API in one pod, we had a worker in another pod. And we also had some deployments attached to each of those pods, not kind of attached, but they were responsible for defining what pods to be created. We then wanted to make our API accessible within the cluster. Bear in mind, again, this is just for one service. We wanted to make our API accessible inside the cluster, so we created a service for that pod. And then we wanted to make it accessible externally, outside the cluster. So we use a combination of two things. We use something called ingress, which defines kind of routing rules within inside the cluster. And we use Nginx, which is a trusted like request proxy web server to handle incoming requests into the cluster and through to our API. And all of that was basically put on one node within the cluster. So we got to this. We were able to access our APIs through from external requests all the way to the API itself, and it kind of worked. Felt great. But we wanted to take it a little bit further and try and make it, more available and stuff like that. So we thought it'd be cool if we could have like 3 APIs or 3 pods running for each service API. And what this service would do, it would kind of just route things to various different pods, API pods, based on what it thought. We did that, but we wanted to take it one step further again. So we thought, rather than having kind of one node, sort of one virtual machine AKS, we'd split that up into 3. So we had 3 nodes, and we thought it'd be really cool to put one pod of each API onto a different node. So if things went wrong, we'd still have some stuff available. It seemed to work really well, but again, we wanted to take it further, we wanted to make it even more available. So we then decided to introduce zones to our nodes. When we were creating the cluster and the node specifically, we could choose, because it's Azure and it's an Azure region and a data center, you get to choose which specific data centers or zones you get to deploy stuff in. So we thought it'd be cool if we could deploy one of the 3 pods to one of the 3 nodes and have one of those nodes in each of the different zones within a data center. So if things went bad in one particular data center in a region, we would still have stuff running, which would be really cool. So we did this for all of the 26 different background services we've got. We had it working, but going back to the conversation Martin had before, he wanted to make it available in different regions. So we just copied it, like to other regions. And again, that seemed to work, and everything was running, and yeah, it was cool. Nothing was using this at this point. It was just kind of like a proof of concept kind of thing. But we wanted one API to rule them all, because each of those clusters had their own hostname, their own domain. But we didn't want that. We kind of wanted one API just to make it easier for people consuming these services. So that's where API management came into play. So these are our 4 different clusters, handling requests coming from outside through Nginx. And we created an Azure API management instance. And the first thing we tried to do in order to get things under one hostname or one domain was to create some APIs. And what this would do, this would allow us to define some rules with regards to routing. So if a request came in on this specific URL, or at least prefixed path, it would be able to route stuff into the right place. And we could do that for each of our different clusters. So we've got cluster 1, cluster 2, cluster 3, cluster 4, and we've got copies of each service on each cluster. So what that meant in kind of reality was that for any request coming into Azure API management, it would know which API to route it to, and then forward that request on to a specific AKS cluster. And it would be handled by Nginx and routed accordingly within inside the cluster. And that's great. Yeah, we got that working, and that's what we've got now in production. It's cool. Like Azure API management is so cool. It's one of my favorite things. I've even got a mug with the logo on, one of my friends got. But we wanted to make this secure, so we chose 2 different methods to make this secure. The first one we used was subscription keys in Azure API management. So each of our different clusters has its own subscription key, and the subscription key was required on the requests coming into Azure API management, and if it didn't match the cluster you were trying to request, it would reject it. So that would make that kind of side of things nice and secure. And the second mode or method we used was mutual authentication, I think it's called, if I remember correctly, or client authentication. So we created some certificates. We put one part on the cluster, the second part in Azure API management, and we attached the public side of things to the forwarded requests. And if Nginx didn't like that particular thing, it would reject requests. Yeah, and again, it made it nice and secure. So these were not kind of public anymore. The API management wasn't public, and it seems to work quite well. But what does that all mean in kind of reality and like how we use it? So it meant we could do this. We could go from having one static IP address with a load of port numbers to some AKS host names with different service URL paths even. And then we could pop it onto Azure API management. So it kind of looked like this. So this meant we would have a single endpoint for all our APIs, which is exactly what we wanted. And this is what we have now. This is what we've got running in production, and it works really well. We also got some other cool stuff out of Azure API management for things like metrics. Like we could see the number of requests coming through to each region, through to each endpoint, and things like that, whether the top number of failures and stuff like that. We know we didn't have those things before, so that was really cool. We got alerted. We didn't really have alerting before, but now with Azure API management, we can set thresholds on if we get a certain number of failed requests coming in. You know, send us an alert. We'll look at it. We'll see what's going on, and then we'll do something if we need to. We got a really nice testing platform as well out from Azure API management through the Azure portal. It's super cool and super easy to kind of test things. You can create requests. You can see the descriptions of all the APIs and stuff like that. It's really nice, really, really nice. And one of the things that we got because of the tier we were on and it's kind of the SKU and so on and so forth, we got a really highly available Azure API management instance. I think we've got it set up in 2 different regions and just 1 instance count in each region. But we can amend that. We can add different locations in if we want to through the Azure portal and whatnot. So yeah, that was quite nice. What else do we get? Scaling. Oh, just mentioned that. Yeah, so we can scale up each of the individual the regions at the same time, I think, in Azure API management. And it was also super extensible. Like we can add new APIs just like that. It's without any downtime really. So we did all this. We did the Kubernetes side for multiple regions. We did Terraform. Sorry, not Terraform. I've just spot the next slide. We did Azure API management, and we provisioned all this with Terraform. I assume most people know what Terraform is, but you know, it's a kind of a way to define your infrastructure as code. It's really good. One thing we tried to do with our Terraform that we wrote for all the resources that we created, we tried to make the resources what we call like region and environment agnostic. So when you define a resource in Terraform, it doesn't know where it's being deployed to, it doesn't know what environment it's being deployed to. That's one thing we tried to do. Well, I'll kind of go through that a little bit later. So our infrastructure kind of code is split up into 3 different things. We have some global infrastructure, things like Azure API management, container registries, management groups, and service principals, and things like that. And we also have regional infrastructure, like our Kubernetes cluster, our service bus, monitoring things like certificates. And the regional stuff, if you just kind of cast your minds back to the 4 AKS boxes, we call each one of those a stamp. It's like a deployable unit that's independent from one another. And then we also have service infrastructure. So we tried to keep the service infrastructure really close to the actual services themselves, so like the C# code that we've got. Because some of the services have like external dependencies to things like SQL databases, Cosmos databases, Azure Function Apps, and things like that. So the way we structured it in terms of repositories, we had one repository with global and regional infrastructure in, and for each service, it's slightly different. So we group services into things called contexts and for each context we have one repository. So I think the repository of the most services is like 5 services in one repository. And we have now currently around 16 repositories with 36 different services, and everything in that repository for a context doesn't know where it's being deployed to. So we can create new environments, we can create new stamps. Should, in theory, all just work. Yeah. So how did we do that? Well, it was quite easy. We just used a folder structure like this. So this is our global infrastructure. We had a main folder with some main Terraform. All the resources are defined within that one single file, but imagine they were. And they don't know where they're being deployed to. And then we just have some other folders with some variables in for the different environments. And then some shared modules that we've written that we could share across all the global stuff. We took a similar approach with our regional infrastructure. So we have stamp 1, stamp 2, stamp 3. Again, just some variable files in there, and the actual stamps or regional stuff is in the main Terraform stuff. And our service infrastructure looks like this. It's similar to the regional stuff, but with no shared modules. So that kind of gave us the ability to add new stamps or new regions really quickly, because what we could do to our regional infrastructure is we just create a new folder called stamp 4, and our pipelines would take care of everything else and deploy everything for us. So this is where we started to use Azure DevOps quite a lot, because we wanted to do super quick and super frequent releases. And we do that with Azure DevOps YAML pipelines. To deploy our infrastructure, we have 2 pipelines. We have a global pipeline, which has 4 stages, and it takes about 9 minutes to kind of go through the whole pipeline, which is quite nice. And then for regional infrastructure, we have 7 stages, which takes about 12 minutes. And the regional infrastructure looks like this. It's kind of nice, I guess. So the first stage is that we plan our changes on the development environment. We can then look at those, make sure everything's okay. And then if we're happy, we have an approval gate just after this first stage. If we're happy with those changes, we then go and make those changes on the development environment. But at the same time, we also plan the regional infrastructure changes on all the live stamps, all the live regions that we have. Again, we have another gate after these two here. I can't put my mouse there, but yeah, this gives us the ability to kind of just look at the changes that are going to be made on any live stamp before we actually make those. And if we're happy with them, we press the approve button, and we use something called like ring deployments, whereby we deploy to the first region, next, everything goes okay, we then deploy to the rest of the regions, and it seems to work out well. So the services pipelines that we have are slightly different because they're doing a lot more stuff. They take about 20 minutes to run, and this is what one of them looks like. So they do things like we build and test our .NET applications. So things like we could have an API, we could have a function app, we could have a worker. We also plan each of the services Terraform within that first stage, just to see if any of the service infrastructure is being made, or if there are any changes to it. We also push some Docker images for the API and for the worker to our container registry, and create new batches if we need to. And then what we'll kind of do, we'll go through all the development and live stamps in sequential order. So what's useful here, I'm not going to move because I think the microphone's there. When we release the first development stamp, it will also plan the infrastructure changes on the first live stamp. So that gives us the ability to see if there are any changes being made. And we've made our pipelines produce a warning on each of the jobs in there to say if there are changes, put a little exclamation mark there, which is a really nice way to see if you can, to see if the pipeline is going to make any changes. Branching strategy, we don't have one. We don't have one at all, really. We have quite a few repositories. We have quite a few teams working on lots of different repositories. So we keep it really simple. Everything's in the main branch. Want to make some changes? Just make a feature branch or something, task branch. Make a pull request, goes into the main branch. Once you're happy with it, we create pull requests. Those are reviewed by other team members. And this means it's like super simple and it's really quick to release stuff to live. And on average, we release our services about 20 times a day to all the different live regions that we've got. And we've also got a suite of acceptance tests that we run every night. Each of the repositories have a collection of tests. We group those together. They do things like create new projects, so they're like real actions you could do in Umbraco Cloud. They take about 2 hours to run, but they're really useful. And we've actually got it working at 100% most of the time. But we do look at them every night, every morning even, and if something fails, we usually fix it within the same day. And then the last thing I want to talk about is something called platform as a product. Like, we have over 40 repositories with lots of things in them. It's global stuff, it's regional stuff, it's service stuff, and there's a lot of stuff that makes up Umbraco Cloud. And we have a lot of duplicated stuff in all our repositories. Things like YAML files, Helm charts, infrastructure stuff, C# stuff. It's basically like you name it, it's duplicated in every repository. So we thought it'd be cool if we could make something called Umbraco Cloud Platform, which is essentially our platform as a product offering. It's just a repository. And the aim of this repository is to reduce a lot of duplication. And it's a repository which contains a lot of stuff like a service template. So if a team or a developer wanted to create a new service, you can go to the platform as a product repository, plug it down and set it up and it'll do it all for you. We've got some like scripts or CLI tools to make it easier. We've got shared pipelines in there, so every service runs the same pipeline. Previously, we had like 15 files for each service in each repository, and it was just a nightmare keeping it up to date. And we've also got things like shared Helm charts, which we use to deploy to our clusters. Again, we wanted to keep it kind of nice and clean, so we just have the one group of files to deploy to AKS. We've also got a collection of Terraform modules in our platform as a product repository, which meant that our service repositories could use these modules to create things like function apps, SQL databases, and it would allow us to create things in the same way every time. And if we wanted to introduce new features or change things slightly, we can make changes to our modules folders, and service owners could choose to update when they wanted to. We've got some packages for things like loading configuration from Azure App Configuration, things like consistent login and telemetry for application insights. So there's a lot of cool stuff in this repository. And then I'm probably going to skip over this because I'm almost out of time. But I'll just quickly go over what we're doing next with Umbraco Cloud. We're doing things like dedicated environments, flexible environments, so you can create whatever flow in terms of Umbraco Cloud projects you want. Kind of automated load balancing, so you can go into your Umbraco Cloud project, click a button, and you will get load balancing. The sustainability dashboard is something we're introducing soon, I think. I don't know if it's already there, I can't remember. But it will allow you to see things like CO2 emissions of your Umbraco projects. Improved UI, which is actually went live yesterday. It looks really nice. And then things like database exports. So you can export through Umbraco Cloud, you can like take backups of your project. And yeah, that's everything I want to say. Thanks for listening.
Hello, any questions for Dan? I guess there are none. Do you have any?
No.
Oh, yeah.
You mentioned about branching strategy and how you have multiple repositories.
Yeah.
How do you handle the situation where maybe different teams all have pull requests up for different feature branches at the same time?
Usually the pull requests or the feature branches, they're so short-lived. Like, they don't really last long, or they don't really conflict with one another. We try and break like our backlog and tasks down into really, really small chunks. And when teams are doing different projects, generally they'll talk to one another, say, hey, we're doing this, hey, we're doing this, and we'll kind of work together just to make sure we don't conflict.
Yeah. Thank you.
Yeah.
Sorry, did you do like your development environment in nodes in the containers, or do you do it locally?
So the development environment is when we're working on our machine, we do it locally, which is with Visual Studio or JetBrains Rider. We'd love to get like Umbraco Cloud running locally on our machines in some sort of fashion, but yeah, we don't really spin up containers locally or anything like that.
I think that is the questions, but I can say this myself. I was someone who's working with Umbraco Cloud, so it's good to see what happens inside the building before we get to see what's in the portal. So thank you, Dan. That was a great talk. We are going to invite our next speaker on stage, so give us a couple of minutes before that, and thank you once again.
Hey everybody, welcome back to Global Azure London. We are back with Anthony, who is going to be talking about Azure Storage and all the cool things going on in Azure Storage. So let's give Anthony a warm welcome and take it away.
Thank you. So my name's Anthony. I'm going to be talking to you about Azure NetApp files and the fact that Azure Storage has never been so cool. Saving these storage sessions at the end of the day is probably a bad idea because, hey, storage is boring, right? Nobody cares about storage. But the cool thing about storage is where data resides, okay? Data is interesting. Everybody cares about data. So all of a sudden, because they're linked, storage is now interesting. So, the Azure NetApp Files product has been around for a long time. It's been generally available within the Azure ecosystem now for almost exactly 5 years. And Microsoft have introduced many enhancements over that time period. And most recently, this particular feature, which we're going to go into talk about. But I suppose, quick introduction to myself. When I started doing talks 3 years ago, one of the criticisms was, hey, you didn't say who you were, what you did, and where you come from. So I took that on board. So here, myself, Anthony Mashford. I'm a cloud solution architect, and I work within the NetApp Azure Business Group. Even though I work for and I'm paid by NetApp, I'm actually all about Azure. My background from Azure extends well over a decade. I've been full-time in Azure since 2014 through various roles, but now primarily a pre-sales role working as a solution architect. But this isn't my first career. My first career was a fisherman. I grew up in Cornwall. I left school at 16 and needed to get a job. And hey, I was living in a Cornish fishing village. So I started to work on the various boats, primarily catching crabs and lobsters. But I got fed up of getting up early in the morning and getting cold and wet, and decided to change career. And I went and I joined Her Majesty, what was then His Majesty's Royal Marines. And quickly figured out I didn't really think that through because I still had to get up early in the morning and get cold and wet. And I spent 10 years in the Royal Marines doing various things, travelling around the world, having fun, etc. And then I decided to grow up and get a proper job. By the way, if you're interested, that's me there. And I entered technology, purely by coincidence, really. I kind of stumbled into technology. Like I said, I've been doing this for well over 20 years, and I've had various roles from engineering, networking, managed services, etc. And as I said, for the last well over a decade now, I've been primarily focused on the Azure platform. And in my spare time, I like doing skids and wheelies and playing around on my motorbike. So the point of this talk, Azure NetApp Files. So a very brief introduction to what Azure NetApp Files is, but I am going to focus on one specific feature which was released by Microsoft to public preview in January this year. I think it's really important to understand this, and believe it or not, even though the service has been around for almost 5 years, this is a Azure native Microsoft first-party service. Okay, an example of the various storage offerings where Azure NetApp Files fits. It's file storage. John did his great talk this morning about the various options around Azure blob storage, etc. But Azure NetApp Files is file-based storage, network-attached storage, delivered by Microsoft, supported by Microsoft, built by Microsoft. Yes, it has NetApp's name in the product, but it's a Microsoft product, underpinned using NetApp's technology, NetApp's hardware, NetApp's software. Why NetApp? Microsoft looked around the technology world for file-based storage service because it was a gap missing within the platform. And hey, they came to NetApp because NetApp has over 30 years experience of delivering network-attached storage services. And the main driver for this was the fact that customers were having issues when they had workloads which relied on these network-attached storage services, running on premises that required high performance, low latency. And I think latency is one of the key things here. Azure NetApp Files can deliver sub-millisecond latency, scalability and simplicity, and advanced data management. And that's the key thing. Azure NetApp Files is underpinned with NetApp's ONTAP operating system and the Waffle file system, which is an enterprise-grade data management platform. Anybody familiar with NetApp on premises would know that. It's a very flexible, scalable service. It's REST API driven. It's integrated into the Azure Resource Management Plane. You don't need to buy any hardware. You don't need to buy any licensing. You simply consume it via the Azure portal or via infrastructure as code deployments using that REST API. And the great thing about it is those workloads which were stuck within the data center because there wasn't this capability to deliver low latency, high throughput, file-based services within Azure all of a sudden now have been unblocked from migration because, hey, Azure NetApp Files exist. It's been GA since May 2019, and it's a very popular storage service. It's still one of the quickest growing storage services within the Azure ecosystem. Volume as a service is what it was originally coined as. As I said, underpinned using ONTAP technology, first-party Azure native service. Key thing to remember. Widest choice of file protocols within the Azure ecosystem for file services, NFS version 3, 4.1, SMB, and indeed dual protocol volume. That is another USP of Azure NetApp Files. There are customers that have Linux backends writing to file shares being accessed by Windows frontends. So the ability to deploy or deliver a volume which can serve both NFS and SMB is super important. I mentioned on-premises bare metal class performance. Now this is delivered using 3 service tiers, standard, premium, and ultra. And that's where you get the throughput as you got the service tiers. The standard service tier, you get 60 megabytes of throughput per terabyte, right up to the ultra tier, where you get 128 megabytes of throughput per terabyte. We'll talk more of those in a minute. But the most important of all we're going to here to talk about is cool access, and we will get onto that in a minute. Already mentioned, advanced enterprise-grade data management platform. It includes all the goodness that you get from NetApp on premises. Snapshot, cloning, replication, backup. All built into the service for you to consume as you wish. No additional need to license these features. You simply consume it on demand for the amount of storage that you are consuming on an hourly basis. And it's an Azure consistent experience, as I said, managed, supported, built by Microsoft. The various workloads, we'll discuss those in a bit, and the verticals, I'd argue it touches all verticals in all industries. I'm part of a European team, but I primarily focus on the UK and Ireland environment. We have financial services, we have public sector, manufacturing, retail, automotive, all sorts. So it actually touches quite a few verticals. So the performance tiers themselves, the standard, premium, and ultra, and as you see, they've got various throughput as you step up the tiers. Azure NetApp Files is capable of delivering up to 450,000 IOPS. Now, if you liken that to the other Azure Files offerings, for instance, an Azure File Share, where you can have up to 100,000 IOPS. Yes, you can burst, but those bursts are chargeable. Okay? If you need performance, if you need throughput, then you may end up in a situation where you need to over-provision storage to get that throughput. This is another thing where Azure NetApp Files helps, is you wouldn't need to do that because you can actually scale well beyond that 100,000 limit. The workloads where they fit. So with the standard tier, things like static content, file shares, database backups, etc. Yes, that's a good sort of starting point for those. However, I have customers that are quite happily running their VDI environment on the standard tier. It depends. It depends on the workload requirement, the throughput requirement. I have customers that VDI would usually fall in, say, premium standard. But I have a customer that's actually utilizing the ultra tier because they didn't need capacity, but what they did need was throughput. These were traders. If you're familiar with trading, the latency, the performance, the response times are super important. It was actually cheaper for them to run on the ultra tier because there is a pricing difference, obviously. As you step up the tiers, the price goes up. So it really does depend. Things like databases, Oracle SQL, they generally focus on premium or into ultra, and then you've got the likes of SAP, and if you're familiar with SAP and how highly strung that is normally premium and ultra. But again, it really does depend on the workload requirement, and there's various tools which I'll share at the end, calculators and assessment tools to actually gauge which would be the right performance tier, both from performance and also cost optimization, because these things aren't cheap. So the Azure NetApp Files storage hierarchy. So obviously, hopefully you're familiar with Azure, okay? So with Azure, you have your subscription, essentially a place to put your stuff. Underneath your subscriptions, you create your Azure NetApp Files accounts. Now, these Azure NetApp Files accounts are where you choose to base your data geographically, where you want your storage to reside. Obviously, in the UK, we have UK South, UK West, and you can have up to 10 of these per subscription. Within your Azure NetApp Files account, you create a capacity pool. Capacity pools are important for 2 reasons. One is where you set the performance, as you see here, standard, premium, or ultra. The second reason, and probably the most important reason, it's where the billing starts. So as soon as you create your capacity pool, you will be billed on a per hourly basis. Microsoft have actually just recently lowered the entry point. The original entry point for Azure NetApp Files was 4 terabytes. So the minimum commit was a 4 terabyte capacity pool. That was lowered last year to 2 terabytes, and this month, or last month, it was actually reduced to 1 terabyte. So you can now actually utilize Azure NetApp files down as small as 1 terabyte. That just made it a bit more flexible for customers who, hey, might not need 4 terabytes, or the way they wanted to carve up their deployment might be by department or by organizational unit, so it could make it a bit more granular. Then within your capacity pools, you create your volumes. So these volumes can be either NFS or SMB or the dual protocol volumes. The smallest volume size currently you can create is 10 gigabytes, and the largest volume size is 100 terabytes. However, what we do have in public preview is the ability to create volumes up to 500 terabytes in size. I've been rattling away a bit. Is there any questions yet? I'm very happy to field questions as they come up. Must be doing a good job. So the workloads, we did touch on them earlier. Azure NetApp Files has really what we used to call 6 hero workloads, or strategic workloads where it fits really well. SAP being one of the main ones, one of the major adopters, even SAP themselves and customers who run SAP on the platform. Azure NetApp Files is the only storage platform within Azure certified to run S/4HANA databases. So if you're familiar with that, that'll tell you, and that's an SAP certification that they've said the storage can meet the performance requirement latency to run the product. Other workloads, so high performance compute, containerization, so Azure Kubernetes Service is a very common workload that consumes Azure NetApp Files. Probably the most common is VDI. So that's Azure Virtual Desktop, Citrix fronted Azure Virtual Desktop, VDI environments, driven by FSLogix. We support FSLogix platform management tools, as well as Citrix app layering, MSI app attach as well. The databases, so SQL and Oracle, another very popular consumer of the Azure NetApp Files product. Where Azure NetApp Files really adds value to those workloads and helps drive down cost and the flexibility, scalability you get with the performance, is it decouples the storage from the virtual machines. So if you're familiar with the Azure concepts, if you're going to deploy SQL, say using managed disks, okay, you might need a certain amount of throughput, a certain amount of I/O. To get that, you will probably need to use those ultra disks and a number of ultra disks, okay? But to get those disks, you need a certain virtual machine SKU to get the number of disks to get the throughput you need for those managed disks. Costs can start to escalate. But by decoupling the storage from the virtual machine, using Azure NetApp Files, and I actually have a really good example of this with a customer, we've eventually finished their proof of concept and they're going into production. They've actually dropped their virtual machine SKU from 48 vCPU down to 16. Now their licensing is tied to those vCPUs, okay? So the less vCPUs, the less licensing, costs start to come down. And what it also does, because it decouples the storage from the machine, they can flex the storage independently. Before they would have to bounce machines, etc. It wasn't as flexible. So Oracle SQL, another really good use case. Another one, in the same vein, by decoupling storage, is Azure VMware Solution. So Azure VMware Solution, hey, Broadcom have screwed the pooch, so to speak, at the minute, haven't they, with their license and everything else and what they're doing with their customers, is becoming a very attractive solution for customers to move into. Like the databases, by decoupling the storage, customers can look now to reduce or to deploy less nodes, because Azure VMware Solution is a HCI solution. It's compute, storage, RAM in a box. If you need more of anything, you need more boxes, and those boxes aren't cheap. Majority of customers are more storage heavy than they are constrained by vCPU or memory. So having the ability to utilize Azure NetApp Files data stores to actually offload the data stores into the ANF product can massively reduce the actual AVS node count and introduce some considerable savings. And again, all the goodness and flexibility that comes with Azure NetApp Files. And the last one, probably the most boring one, I guess, but unstructured user data, departmental shares, home folders, okay? This is becoming more and more attractive because of this next feature, which we're going to talk about, which is the cool access feature. The ability to just consume storage. You don't need to be a storage admin. I've been working with one of the largest online retailers in the UK. They've moved on to Azure NetApp Files. They used to have a different storage option, but they had to learn how to manage storage. These guys were developers, they were DBAs. They didn't want to manage storage. They migrated off that platform for a few reasons: cost, performance, and operational capability. Those are the three challenges they were having. They migrated onto Azure NetApp Files throughout last year, and It was difficult because it was the lifeblood of their platform. It was integrated into their website, their main trading platform. So it was quite a difficult move for them to achieve. However, what they did do by moving to Azure NetApp Files was to reduce their batch processing time by 50%. And these were Oracle batch processes which ran overnight, and essentially they had to be back online for the working day. Sometimes they would take longer and stray into the working day, and that caused business challenges. But by being able to use the scalability, flexibility, low latency of Azure NetApp Files, they reduced that batch processing time by 50%, which then gave them a huge window to react if things happened. Also, they integrated all of this into their DevOps pipelines. The snapshotting, the backup, it's all integrated into their DevOps pipelines, which run those processes. So it's all done using code, which they love, because as I said, they're developers, they're DBAs. But most importantly, it knocked over $200,000 of their Azure consumption across the year. So it actually saved them a huge amount of money. So the unstructured user data piece, why has it suddenly become interesting? Why is Azure Storage getting cool? Cool access tier. So Microsoft introduced this cool access tier in January this year. What the cool access tier does, it gives you the ability to tier data out of the ANF volumes into essentially what is ZRS storage. The metadata still lives in the volume, so the application, the end user still sees the data, but the blocks of data are residing in a much cheaper storage tier, and it can introduce considerable savings. It depends how cool your data is, how much data you retrieve, etc., and there is a TCO calculator to help you gauge that. But it can introduce a considerable saving, but maintaining all that enterprise-grade data management capability as NetApp Files. It's massively driving down the price point. As I mentioned, the hot data resides in the volume. The metadata also data that gets cooled based on life cycle, which we'll see in a minute. That's essentially set at either between 7 or 183 days. The default is 31 days. But once data reaches that age, it is tiered out of the volume into ZRS storage. Like I said, the metadata still sits in the volume. So your end users aren't panicking. Where's my data gone? Your application's not going. I can't do anything because it can still reference the data, but the blocks of data are much cheaper storage too. So how this works. So the data blocks are written and they have a temperature set as hot. The temperature scans data, and as I said, you can set the life cycle to be between 7 and 180 days, the default being 31. And once it scans and collects those cold blocks, basically packages them all up, bundles them into 4 megabyte blocks, objects. And then it essentially moves them transparently. This is all transparent, by the way. So your end users, the service is all done within the service itself. It drops them essentially into ZRS storage. And then the data is recalled, and there is a recall policy you can choose, whether it's on read or don't recall or whatever. So you can set the policies across the service. That's how it actually is recorded. But it is introducing a considerable cost saving. Now, what I've done with estimates, if you're familiar with the Azure Files offering, you've got cold, hot, transaction, premium. It's bringing the price point for the Azure NetApp Files service. By the way, this is only available at the standard tier currently. So the standard service tier, which is where unstructured user data would probably reside anyway at the cheaper, less performant tier. But it's bringing it around about the price point of Azure Files Hot. That's an example. And if you're familiar with the limitations or characteristics of the various storage tiers which John talked about this morning, they have challenges around pricing, especially, transactions. Hey, how many transactions am I going to spend this month? I don't know. You get the bill shock at the end of the day. Believe me, I've worked with customers who've had massive shocks on the bills because of that. But you still get all that capability to snapshot, to backup, to replicate as well. The Azure NetApp Files product, unlike, say, Azure Files, so if you were going to compare apples with apples, you would compare Azure NetApp Files to Azure Files Premium tier. Azure Files Premium tier only has local and zone redundant storage options. Azure NetApp Files has inbuilt backup and replication capability. So you can replicate a volume to one of the paired regions, UK West, UK South as an example. All part of the storage service. Doesn't happen at the network layer, it happens at the storage layer. So it's very efficient. Block level replication. Yes, there is a small charge for that replication because you are crossing regions, but it's nowhere near as expensive as network level bandwidth charges. So this also works with that replication technology. So you have your standard tier volume with cross-region replication configured. You enable cool access, and the great thing about this is the way that it works. The cool access replica is automatically carried over to the replica volume in a partner region. So you configure it once, and then whatever you do on what's called the source volume is replicated to the target volume. Again, you can leverage all that saving across regions as well. The cost optimization thing is key because every single customer I talk to, everybody I work with at the minute, everybody wants to save money. Even if it's 2 or 3%, they want to save money. So this is introducing quite a reasonable saving. There's an example of here based on how much data, how cool your data is. Realistically, the amount of data which is relied on in storage, how much is being accessed or needed? 5, 10, 15% maybe? The rest of it just needs to be there. How much data is going to be recalled? And that will give you savings. And realistically, what we are seeing for the customers, bear in mind this service is still public preview, and I would never urge anybody to use anything until it went generally available. But the customers who have opted to utilise the service in the previous state, savings are hovering around between 40 to 50%, depending on how cool, how hot, how much data is recalled. So it is introducing quite a compelling saving for storage. I forgot to ask what I probably should have asked. Has anybody heard of Azure NetApp Files or using Azure NetApp Files?
What was the question again, sorry?
Has anybody heard of Azure NetApp Files or is actually using Azure NetApp Files?
I heard, but
What are you using it for? Can I ask?
Just for like a cloud SAN almost.
Yeah.
Big storage.
Just file storage. No workload driving it, just shares, folders, etc.
Yeah.
How are you finding it?
Yeah, it's good. I mean, it's fast.
Fast, yeah.
Yeah, very, very fast.
And fast is one thing. I think simple is another. It's a very, very simplistic service to work with. Like I said, you don't need to be a storage owner. You can just consume this. You can drive it via REST API. You can do it via the portal. Another analogy, or another sort of anecdote was, I've been working with a very large GSI. They were looking to stand up the project team to do quite a large migration. The project manager was asking the architect, what persona do I need in the team? Do I need a storage architect? He was like, no. Do we need storage admin? No. They can do it so easy. It's such a simplistic service. Also, by the way, there is this aggregated site, so aka.ms ANF tools, where the product team have put together some performance calculators, TCO calculators. To give you an idea, there's a link to the YouTube channel, which the product group run, capacity managers, and also quite a cool little PowerShell script here, which you can schedule and run via Runbook, which will give you a health check on your ANF environment on a daily basis, or however often you actually schedule it. So I'm just going to dive out of this now and just quickly show you the service. What I've also done as part of today is, hopefully you can see that okay. In my GitHub, I've created a repo which has got some Terraform script, and Terraform seems to be a common trend today, so I thought, hey, why not? I'll do it as well. So there is this repo here which I can share with you. It's basically, if you wanted to go and play with the Azure NetApp file service, there's a very basic lab created, which if I just actually go into the code, hopefully see that a bit better. So this is essentially what's in it, and what it's going to do is going to build VNets. It's going to create an Azure Key Vault, because it's going to create a secret in the Key Vault. It's going to use that secret to actually do all the cool stuff it needs to do. It's going to create the VNets. It will create a subnet, because Azure NetApp Files need a dedicated subnet. The way the Azure NetApp Files service is brought into your infrastructure is via a dedicated subnet within your VNet. So it's going to create that. It will create accounts, capacities, and volumes. It would also do the replication for you, so you can then have a functional ANF environment to go and play with, beat up, break, test yourselves. Quite straightforward, really. And as I mentioned in the repo here, there's a few guidelines about how to do it. And essentially, a visualization of what it will do. As I mentioned, it's going to create a big Key Vault secret, accounts, capacity pools, even Linux virtual machines, which you can then go into. This is only going to do NFS volumes, because obviously with SMB, you're going to need Active Directory. And I can't configure Active Directory through a PowerShell script in a minute and all this stuff. I can, but it's laborious and it never seems to work properly, or if it does work, it's a hit and miss. But ultimately, you would need domain controllers. You would need a whole domain infrastructure to do that. So this would build you an NFS environment with a Ubuntu Linux machine, which you could then play with. And The various instructions are down there. Once you've actually got the code, you can actually just run. Terraform's quite basic, quite intuitive language to work with as well, so you should be able to figure it out. What does Azure NetApp files actually look like? So in true Blue Peter fashion, here's one I created earlier. So this is that lab that is in the GitHub repo. These are the resource groups which it's created. And in here, the resources are created within it. So your Azure NetApp files accounts, capacity pools, volumes. You will also see it creates these network interface cards. That is a requirement because it's network attached storage, right? It needs to talk to the network. So you'll see those being created in there. Always get asked the question, I don't like the name of the network card. Can we change it? No, sorry, you can't, because it's a managed service, right? It's a multi-tenanted managed service, which is all created for you. So that's just one little idiosyncrasy you can't change.
What's the capacity pool again?
Pardon?
What's the capacity pool?
Okay. So a capacity pool, if you're familiar with storage, imagine a capacity pool as an aggregate. All right. If I just show you, so if we just jump in here, so let's have a look. This is an Azure NetApp files account. Hopefully, zoom out a bit. So within the account, it's quite basic, really. It's basically the geo where you want to put your storage, your data. You can set up things such as the Active Directory connection. Sorry, I'm going to have to put my glasses on because I'm getting old. My eyesight's failing. So you can configure Active Directory connection. So if you require AD, you can set your DNS name. You can put the SMB server prefix. That's a 3-character prefix before the volume. The machine name it creates. Because what this does, it creates a computer object in your Active Directory to then leverage NTFS permissions. That's what it does. So what is a capacity pool? By the way, encryption. This went GA in January. Hurrah! Customer managed keys. So if you do need to manage your own key, you have platform managed keys or Microsoft managed keys, or indeed customer managed keys as an option in conjunction with Azure Key Vault. That is available. So to the next question, what's capacity pool? The capacity pool, imagine it's like an aggregate. It's a block of storage that you can carve up to choose what you want to do with. And that depends on size. So this here, I have a capacity pool, which is 4 terabytes. If I suddenly needed more storage, I can choose to expand that. So now I want 6 terabytes. It's only take a few seconds, there we go. So I've now gone from 4 terabytes to 6 terabytes of capacity I can use. And bear in mind the capacity is also linked to performance. So if you need more performance, you might need to have a bit more capacity. It really does depend on the workload, etc. Likewise, if suddenly I decide I don't need 6 terabytes anymore because I might have over-provisioned to get a bit of performance for a period of time, I can go resize that back down again. So essentially that's what the capacity pool is. So standard, so you have a capacity pool and you choose your service tier. Standard, premium or ultra capacity pool. And that's what gives you your performance. So a 4 terabyte capacity pool, the standard service tier is going to give me 64 megabytes of throughput available to assign to volumes within the service. This is a manual QS pool. You can also have auto QS pools. With an auto QS pool, it automatically assigns the throughput to the volume based on its size. With a manual QS pool, you can independently assign the throughput to a volume. So you might have a volume that says is a data volume, and you might need a bit more throughput, a bit more oomph for that volume. So you can assign much more throughput to it. You might have a backup volume, which you don't need as much throughput, so then you can assign less to it. Manual is always, the default is to auto, but I would always suggest use manual now because it's just much more flexible. Some customers still prefer to use auto. That's just what they work with, but it depends. Yes.
Assuming you can't decrease the capacity if you've already assigned it to a volume.
Yes, so yeah, extremely good point. So if you've got 4 terabytes of your capacity pool and you're consuming 4 terabytes for the number of volumes in the capacity pool, yes, you can't. But where we see customers using this to good effect is where they have weekly or monthly jobs, right? Payroll being a good example. You know when it's going to run. You're going to need the performance when the payroll's running. So you can scale the capacity pool up, scale the volumes up, give them more throughput, and then shrink them back down. Some customers actually take volumes, which you can do, take a volume from the standard service tier to a higher service tier, so the premium, right, to get more throughput, more performance. The only caveat there is there's a 7-day cooling off period. So you have to wait 7 days before you can move the volume to a lower service tier. But still going to be saving money for 3 quarters a month, right? You still leverage all that performance. So yeah, Nick, hopefully that's answered what capacity pool is, yeah? Within the capacity pools, you can create your volumes. By the way, I mentioned a few other capabilities, the snapshotting. You know, I think this is something as well, we've failed to sort of hit home hard enough how important snapshotting is with NetApp's technology. It's extremely efficient. The snapshots live in the volumes, but the overhead they have is 5–10%. I've seen customers with more, but depends on the type of data, how much churn the data actually sees as well. But snapshots are a fabulous way to protect against ransomware. They're a point-in-time copy. You know, they're instantaneous. You can report in test dev scenarios, they're priceless. You know, you can snapshot a volume, take it away, attach it to a machine, do all your testing, finish your testing, throw away the snapshot. And there is a lot more capability coming for snapshots. And you can set policies, hourly, daily, weekly, monthly, how often you keep them for your retention policies. Likewise with backup. So ANF Backup now uses a backup vault. This isn't part of Azure Backup Center. It's part of the ANF Blade, okay? So it's not, annoyingly, it's not integrated into Azure Backup Center. But again, it comes along once a day, and it hoovers up the snapshots and puts them into ZRS storage. So it takes them off of the ANF media and drops them onto different storage, which is, hey, that's what you want your backup to do. Right? I've got a customer using this to really good effect, where they have snapshots that are heavyweight, and they do have a greater overhead on the volume, because then the volume gets larger, right? But what they've done is they've balanced the snapshotting and the backup with their RTO and RPO with the business as to how rapid recovery, how the recovery points and recovery times, and using that ANF backup to offload the snapshots, therefore lowering the capacity and the volume. Okay, so it depends how you carve it up and how you get with it. Okay, so we look at the volumes themselves. This particular volume here, it's NFS volume. Microsoft do a really good job. They give you the mount path, okay? But not only do they give you the mount path, they actually give you the mount instructions. So if you're not that familiar with the Linux operating system, they tell you which packages you need to install, and then they give you an example of this mount point, which is hidden beyond that. So, important points to take note as well, because of optimization, performance, etc., packet size and everything, to use that mount point. Snapshots of cells, you can see there's probably a snapshot in here because this has replication enabled, and this is what's called SnapMirror. SnapMirror replication is a NetApp technology, and it's snap mirroring from this volume to the target volume, which in this case is in the West European. If you had snapshots within here, you'll be able to recover from. To create a snapshot, you can do this programmatically using code, or do it manually like I'm going to do now. To create a snapshot, just give it a name, click create. And that's it. I've got an instantaneous copy of my volume. If I wanted to then take that volume, that snapshot, I could restore it to a new volume. Or I could restore individual files from within the snapshot, or I could just revert the volume. Very flexible. Conscious on time. Am I still okay?
A couple of minutes.
Couple of minutes, cool. So, replication, we mentioned that already. You'll be able to see within the portal. So a lot of the metrics are exposed within the portal. I'm in the middle of trying to cobble together a workbook. My KQL knowledge is getting much better over the last few weeks by doing that. But yeah, so Azure metrics, it's an Azure system, right? So what we work on, hopefully be able to give just a nice overview, because hey, management like pie charts and graphs to look at statistics and that, don't they? The backup itself, what we also have now, which is GA, is user and group quotas. So you don't want, if you're just using unstructured user data to default managed shares, you don't want your users taking control, owning, or just filling it up for no reason at all. So you can say, you can have a default quota where users are only allowed to consume, I don't know, 50 gig. And then you can have individual quotas, where you can say actually that someone can have more or someone can have less. So you can, it's much more capable from a management point of view. Cool. So just hop back to the presentation.
One question.
Sure.
Those users and group, is they both based on EntryID users, because the backup is not based on Azure Backup?
Great question. So Azure NetApp Files for authentication only supports Windows Active Directory, or the product formerly known as Azure Active Directory Domains EntryID, right? So not EntryID, not the solely cloud identity. It needs a hybrid identity. Essentially, it needs Windows Active Directory or the domain services, the service. Sorry?
Or Linux, SMB?
For SMB. Okay. For Linux, it's not unless, it depends. It supports LDAP for authentication, so you can use an LDAP authentication, open LDAP, for instance, right? But for SMB, then you're going to need Windows Active Directory, right? But there is, I actually had an article published on the the Microsoft Community Tech Community site, where customers that use AVD session hosts, which are Entra ID only, joined, because they benefit from Intune management, providing they have a hybrid identity, i.e. the user is authoritative in Windows Active Directory, synchronized to Entra ID, then that works. There is a method there, but ultimately it still relies on conventional Active Directory at the minute. There is this tool site, as I mentioned. Also, if you want to keep up to date with Azure NetApp Files, Microsoft have an Azure NetApp Files page, so you can jump on there and you'll see various releases. The cadence has been crazy recently. The team was massively hit during the pandemic, right? The development of the service really got slowed down, as I think as many other services, and they're playing catch up now. We have services, features that are in preview. The main part of this semester's development is to get those features out of preview stage into GA. One of the cool things as well is things like double encryption at rest. I've mentioned the customer managed keys. That has been huge for mostly financial customers or legal customers, but super important as well. Double encryption at rest, that is now available. However, that comes at a premium. You have to pay a bit more money for that, but if it's a requirement, you need it. So that's it. Thank you. QR code. We all love QR codes, right? If you want to have a QR code, but any questions, John?
Question. You don't happen to know, you mentioned about SQL being a good use case for it.
Yeah.
If managed SQL instances you can attach volumes to, I don't think you can, but
Not for managed SQL. We're talking SQL on the box. So
that's what I thought. Yeah. So yeah, because
there is development coming to be integrate into more, let's say, native services. But this is infrastructure. We're talking mainly not all. We do integrate with some things, but yeah, for managed SQL instance, no.
Thanks.
Well, thanks, Anthony, for that wonderful talk. I think we will now get Amy set up for the closing keynote for the day. So just bear with us for a couple of minutes and then we'll have Amy on stage. Thank you once again, Anthony.
Hey everyone, I am actively keeping you from going home, so let's crack on. And In this session, it's got the strangest title, but honestly, it will all make sense shortly. You have learned so much today. What I kind of want to do is just make sure you know kind of what's available to you in the AI space from Microsoft and where you can connect with us at your leisure to go and learn a little bit more. You've taught storage, you've taught infrastructure of code, you've taught containers. So we're going to focus in a little bit on AI. There's obviously a lot going on in this space. My name's Amy Boyd. I lead our AI advocacy team in developer relations at Microsoft. And one of the things that we say our mission is to make Azure the easiest place to build and deploy AI solutions. And now that includes co-pilots. How many people have heard about co-pilots? Yeah, good stuff. Otherwise, you've been hiding under a rock. And well, in the Microsoft ecosystem, at least, we definitely talk about them quite a lot. There are also quite a lot of them. And so, one of the interesting things I want to talk to you about today is a little bit about how we break them down. Another thing I want to speak to you about is I actually have a team that worked around something called the Microsoft AI Tour since October last year. We are a team of 15 advocates and we're all across the globe. So Australia, China, lots of Europe, Middle East and Africa, and on both coasts of the US. So we're definitely a global team. We work 24 hours a day at this point with teams. But one of the interesting things we do get to do more recently is start to go and meet developers and customers, like I am today with you. The tour has been a really good way for us to get people hands-on. It's been a really amazing way to just demystify all of the different things that are happening in the AI space and just have people sit down for a day and learn a little bit about the Microsoft AI space. We did have one in London. This is me in London, Scott Hanselman. We did the keynote. It was great fun. London was packed, which shows obviously a lot of appetite for Azure AI and all that we are doing in this space. But as we are nearly on our commute home here, I wanted to talk a little bit more about what I've overheard at the Microsoft AI Tour. So I'm not going to stand here and do a quick summarization of everything we learn when we're on the AI Tour. I want to fast track you a little bit. I don't know if you found this, but actually getting back together in person, a lot of the value of these types of events is actually the conversations that happen. And often, you know, the active crowding around the speaker at the end to ask lots of different, more specific questions. If you ever just go and stand by that crowd, it's fascinating how much extra that you learn just standing there for another 5 minutes or so. And so what I want to do is just fast track you a little bit, and I've crowdsourced all of those different questions. When I was doing this, it reminded me of something that actually we have here in the UK specifically. Has anyone been on like the social media account called Overheard on the Tube? Yeah, it's wild right out there, but similar kinds of things, right? You'll hear all the wacky and wild questions at those kinds of end pieces. You'll hear about everyone's ideas and kind of what they're thinking of building and stuff like that. So, as I say, yeah, I was going to say, so it's, you know, the social media version about the tube is a little bit more crazy. I want to just give you some interesting information about the questions. So let's jump straight in because I've got a few. If you don't know what something is as a specific product, hands up and just shout out. Don't know what that is? Can you tell me a little bit more about it? And I'll give you a brief summary. I am also a co-pilot. No, I'm joking. So first question that comes up more often than not, that one we're actively addressing actually, is when do I use, for example, Azure AI Studio, Azure OpenAI Service, or Microsoft Copilot Studio? 3 different services, 3 different ways that you can build generative AI solutions. So why have we done that in some senses? So I'm going to take a step back for you and talk through this diagram instead. And this is probably going to help you with all the tag words around co-pilots. So in our ecosystem at Microsoft, we see co-pilots being available across our whole platform. So although I work in the Azure part of our organization, actually there is co-pilots everywhere. Many more than can fit on this slide. But how we break them down can can help you to understand where to look first and what exactly it is that you're looking for. So as an AI team, someone might come and talk to me about Copilot for Dynamics 365, and they go, well, it's AI, and you're the AI team, so tell me more about it. And I'm like, whoa, let's step back. So we have 3 categories. Adopting a Copilot, sounds like you're adopting like a wildlife animal, adopt your own zebra. Extend a Copilot, and then build your own Copilot. And one of the things I would say is it that you're consuming AI, so you're just using something rather than building it? Is always the easiest way to think about the 2 extremes of this. So some good examples listed there. Copilot for Microsoft 365 is the one that tends to be the most talked about at the moment. Available on your desktop, available in the browser, Bing, Copilot. It is a model that we have built as Microsoft that is available to you and connected to all of your M365, internal enterprise kind of information. The value is the information that it can get hold of, summarize, ask questions of, etc. So that work sort of view of it. I call this using AI. You will use AI when you use ChatGPT. You will use AI when you use Bing. You will use AI, this is a controversial one, you will use AI when you're using GitHub Copilot. That is not you building the Copilot, you are using it to be more efficient at your job, right? So GitHub Copilot is probably the one that's most recognised in this room as well. So that is adopting, that is using AI. In the middle, we have extending AI. So it's fascinating how quickly some people try out something like Microsoft 365 and then they go, but we need this very specific thing for our organisation. Naturally, it's what we do with Azure, it's what we do with Office add-ins, Office apps, stuff like that. And so we've created the ability for you to actually extend, for example, the Microsoft 365 Copilot, and you can actually do it through something called Microsoft Copilot Studio. Microsoft Copilot Studio, if it helps everyone, sits in our Power Platform part of the organisation. So if you've used Power Automate, Power Apps, Power BI also technically sits under there as well. It's this idea that you don't have to be a full-on developer to use this. It is a low-code version, but there are a lot of parts of these platforms where you can actually use code, or you can connect it to other things as well, such as your own custom pieces. You can also just build Copilots from the ground up in Microsoft Copilot Studio. And one of the interesting things I've found personally is there's often, if anyone's used the Microsoft bot framework in the past, one of the things I found most fascinating about it was actually the integrations. After I created my chatbot at the time, I could just deploy it to Teams in like a click, and that was really a really good, feeling, especially if I was doing something inside my organisation. It felt really simple and quick and easy to do, rather than having an API endpoint in this bit that actually interacts with your model, and then you have to build it into a Teams app that then obviously becomes available to you. So extend in the middle is like best of both worlds. It almost feels like you can extend, you can create your own, but you don't have ultimate control, right? You can't build everything custom. You don't have every decision available to you. And that's where we get to building your own Copilot. And something like Azure comes back into the picture, where you're going to have a set of developers, a team who manages and maintains these Copilots over time, monitors them, applies responsible AI to them, etc. So hopefully, even just this simple slide has said, to break up all of the Copilots, are you using the Copilot? Are you extending the Copilot or using low code? And then do you want full control over the Copilot that you're building? And it's very much custom code and custom deployment. So yeah, a nice sort of diagram. I'd like a better slide for this personally, but we'll get there.
I have a funny question.
Sure.
How many Copilot does Microsoft currently have?
Difficult to keep up with. I think last time I heard from someone, it is up there in the sort of plus 80. So there is a lot. They are everywhere. I mean, if you think about Microsoft Fabric, anyone used Microsoft Fabric or looked into it,
each workload potentially has a co-pilot, right, associated with it, whether it's data factory, whether it's your data lake, whether it's writing the actual code that's accessing your data. It very much depends on kind of what you need in there. So it's fascinating to see how they very quickly become many, many multiples. But the key thing is having that assistant in the product is a really good experience. And yeah, it's exciting to kind of see what is available and how it's tailored.
Copilots align to each other. For example, GitHub Copilot is very similar to Azure Copilot for Azure, because Copilot for Azure is only for Azure focus in the portal.
Yeah, I was going to say.
I don't know whether there's anything on the roadmap for bridging the gap between having one, because people like to have more Visual Studio Code.
Yeah, so
having two.
Yeah, no, it's an interesting concept, but think about as well, like what does a Copilot do in the instance that you're in, sort of thing. So when you're in GitHub Copilot, you're in that mentality of coding. It is grounded and designed and efficient for answering those questions. Can it tell you a taco recipe? Yeah, but like, is it useful to do so? Yeah, I was gonna say. So it's an interesting one to think about, like, if you're building your own Copilot, what is it that you want it to actually do for your customers? The answer is not everything. I don't think that's always a good use for a Copilot in most cases. That's my personal opinion. These three are very specific to building your own custom Copilots. So you've said, look, yeah, cool, M365 is great, but what else can I actually do? And Microsoft Copilot Studio being lent into, if you have M365, if you have licenses around Power Platform already, go check it out. Wonderful service. Built on a lot of what we've done already in the Power Platform, and so is in a really nice state. Azure OpenAI service was obviously a new kid on the block not so long ago in partnership with OpenAI. This provides OpenAI APIs available quickly to developers with all the enterprise security, trust, and data security and privacy around it, right? So this is a service just for Azure OpenAI specifically. And then you also have the Azure AI Studio in the middle. Azure AI Studio is going to be the one-stop shop for every Azure AI solution that you build. So whether it's choosing the specific models that you want to do, there's a lot of, I don't know if anyone saw yesterday, Llama 3 was released. It's interesting to see like the cadence at which these new models are coming out, why you should choose them specifically. They're all tailored and more efficient for certain things. And obviously everyone's trying to benchmark each other as well and make the most relevant returns as well around them. But Azure AI Studio is very much that end-to-end. We saw Azure Machine Learning earlier. It's a very similar idea. You take it from building, applying data to it so it grounds your model, so it brings it back to a context that you want it to answer for your customers, as well as deploying, managing, maintaining, and evaluating as well. So again, a lot of custom and power there, if we want to call it that, and you have to decide whether that is something that you are looking for in some senses. So that was kind of which service do I use. We have quite a lot. Definitely go and take a look at them. Azure AI Studio, Microsoft Copilot Studio are two great ones to go and just have a read around, check out a YouTube video on, and get a sense of, is it something that you are looking for specifically?
Sorry, one more question.
Sure.
No, you prompt me with a question. Which part of AI Studio did you say you can code? Because it's what you said before, it says mostly for kickoff, people that's low code, so developers can do it. So which part of this service in AI Studio that you can probably Terraform bicep code it?
Yeah, so interestingly, the code first experience for Azure AI Studio is the one that is being worked on quite a lot. You can bring something called prompt flow, so a way that you can design how your large language model answers questions, gathers data. That's available in Visual Studio Code. So you can go into that code editor or code spaces, for example, and you can have a little bit more control on your local machine around what it does. And then we also, as we always do with Azure, have the sort of more UI abilities to do it. And often looking at results in there is a really great way to look at it as well. Great question, though.
They do have a pipeline in machine learning. It's weird. when they went in there, they were still playing around with it. They have like a pipeline, which was triggering from like start to end.
In Azure machine learning?
Yeah.
Yeah, no, definitely. I was going to say pipelines are very important with machine learning projects because you don't just like one and done type thing with machine learning models and large language models. These things need to be looked after, they need to be maintained, they need to be evaluated to check that they don't drift with data, that they continue to be as accurate and answer the types of things that you're looking to answer as well. That's a good question. Next question I get a lot about is more on the data side. So with these large language models and generative AI, one of the interesting things is the data storage. It's interesting we've had so many storage conversations. Data storage has become much more important and considered as well. How are you getting access to these different things? Does anyone know what a RAG workload is? Do you want me to quickly... RAG stands for Retrieval Augmented Generation, and one of the interesting things about that is these large language models have obviously, some of them are absolutely huge, and they have context, if we want to call it that, of so much information. But when you actually want to build a copilot for your business, it's probably less likely you want it to provide you recipes unless you're in that business, and it's probably more likely that you want it to provide your product information, you want it to personalise to your customer and what you know about them and have it as that more personalised experience. From a responsible AI point of view as well, grounding these large language models down to something that is useful to customers is probably going to be a better outcome accuracy-wise, because obviously we understand these large language models are based on statistics. It's the probability of the next probable word that comes after. It's not actually, you can't actually say it understands or has knowledge. It's all about statistics still, just like machine learning is. And so one of the interesting things is Azure AI Search has become a big product, one to note down. Azure AI Search was built on top of Azure Cognitive Search, if anyone has used Azure Cognitive Search in the past. A really, really great way to kind of get to index lots of different types of data that you can then extract insights from and easily search over all of that data. And in RAG workloads, one of the key things about these models is you're actually then adding data that's relevant. So you've got this language model, it can give you context, but it can't actually it's able to go and look into your data and then bring context back to the answer that it's going to provide. It could bring back references to documents. It could bring back customer information, for example. So you might have a retail bot. Retail's always a really good one to demo with. And you say, hey, I'm looking for a yellow tent that's less than £250 or something like that. And in that context, it'll actually say, oh, hi, Amy, because maybe I'm logged into the website. You actually bought this before, and so we would recommend what partners with that is this. So much more personalised, so much more useful in some senses. I can easily say, actually, I'm here to browse. Give me the top 5 different things that I could buy that is a tent and is less than $250, and then it's probably going to go into your product catalogue. So unless that information is available on the public internet and a large language model has consumed it, it won't have the knowledge of that. And so RAG workloads are becoming very popular to ground these models based on your product data, your customer data, etc. Azure AI Search is a service that has been built specifically for that. But the question is, well, we've already got, maybe you've already got Cosmos DB, maybe you've already got Postgres, for example. And actually, these databases are now moving in the direction that they can do vector search. Vector search is important because it's able to not just do keyword search, like if you search on a search engine and you put Jaguar, it's doing contextual search of, do you mean Jaguar the animal or do you mean Jaguar the car, for example, is a great one. And depending on the context of the search, you can go and find the relevant information. So another good one is if I say something like, got me going a bit ad hoc here. If if I say something about, I don't know, a product, so a dress or something like that, it might say, oh, something that relates closely to that is pairing it with shoes or is pairing it with a bag. Something that's completely not related to that is maybe the Uber that you're going to go and book later or something like that. These things are not close in what they call the vector search space, and so it won't return this information and it'll capitalize on this information over here. So that's how it can be so broad as well and make interesting decisions. But one of the interesting things you can have vector databases if you already have products inside an Azure Cosmos DB and that's all that you want to use for that RAG scenario. You just want to make sure that the products are available. You can actually just use the native vector search here. The only thing we would say is the best relevance service, the highest quality of results being returned to you at the moment is through the Azure AI search, and it's not, you can actually connect all of those different sources and it can go and kind of connect to them, so you're not having to move all of the data, you're just kind of peering at it a little bit. But then on the other side, you can also add new data, because now things like files and PDFs and things that have maybe forms and stuff like that is actually data can be extracted from that really easily. And if anyone's used Azure Cognitive Search in the past, you might recognize this diagram. And what it is actually doing as Azure AI Search is bringing in the data from any format or store. It's enriching it with these cognitive skills, and cognitive skills now include some of these things like vectorizing and searching across, and you can add all sorts of different skills to this: vision skills, text skills, OCR skills, etc. And it stores it in a knowledge store that can then be obviously searched over. And the search is what it brings back to your Copilot. You got a question? No worries.
They have different names, cognitive skills, and it was AI search before, now it's cognitive skills.
Yeah, so sorry, this is actually the context of what's happening behind the scenes. So that's not the service, sorry, this is all within inside that service. It does all of this piece. But cognitive skills can be all sorts of different things. You can even build your own custom cognitive skills.
So it's not the skills in AI search?
Yes, yeah.
No, it's that one, okay, because they have a different name, that's why I call.
Okay, yeah. This is an interesting question that people often come out with as well. People immediately get into the thing of, okay, these large language models are way too broad. I'll fine-tune it down to the scenario that I need to do. Fine-tuning takes a while, is quite complex. And obviously, when something takes a while and quite complex, it might cost quite a lot as well in some senses. So you have to decide when the right time is to do whatever approach. Now, with large language models and generative AI, there's multiple different approaches. The one you're most familiar with is probably prompt engineering. So when you're chatting with any of these copilots, you're prompting it. That's what we call it. When you actually type in your question, you send it a prompt and it returns you a result. You can actually add loads of stuff to prompt engineering to really get it to orient to the right answer in some senses. You could say, you should say, it's best practice to ask a question and say, summarize it in less than 100 words or deliver me 3 bullet points back that summarizes this document. By giving it more context of exactly what you want, you're more likely to get the information that you're looking for returned. So being really explicit is a really good way to do prompt engineering. A lot of the time, people will do prompt engineering where you'll ask it once, it'll come back with something, and then you'll say, yes, but can I have it in this format? Can I have it with this information? Can you take out this part? And then it will return again. And obviously it's got the history and the context, so it can do that. The only thing about that is every time you send a prompt, it's a set of tokens, and tokens cost money. So one of the key things here is how quickly can I get from my question to my result and it be exactly what my customer is looking for. So if you've tried prompt engineering and you're not quite getting back what you're looking for, that might be when it's a good time to look at something like retrieval augmentation. So where we said pull in my products, my customer information, that's going to give me back a better relevant result. Or consider fine-tuning. I really liked this slide because it explains it quite nicely. RAG is all about it learning new facts, and it learns them temporarily. It learns them within inside that conversation. It's not, when you pull in those documents, it is not changing the model. So it's not changing those weights in the model. It's not technically learning anything new. It's just going and looking for some relevant information and then providing it as part of the answer. Fine-tuning is different. That is where you are teaching the model to do something different from what it originally does. Learning new skills permanently. One of the really nice ways of explaining it was, I've actually got on my next slide, was in this video, if anyone wants it. We have this show called the AI Show. We cover pretty much every Azure AI technology that we do, and we speak to the product teams who are building it, and they give us some really great insights. So definitely check out the AI Show. The specific episode this will take you to is to fine-tune or not fine-tune, which is quite fun. But one of my favourite pieces about this is they kind of use a really nice analogy that I've noted down here. Is basically that your RAG scenario you could think of as an open book exam. So you have all of the information in front of you. You've just got to find the right information and put it and get it to answer the right question. Whereas fine-tuning is much more along the lines of you're learning something over time, and then you go into an exam and you should just be able to answer those questions from what you've learned. You apply a framework more than you apply sort of just pulling specific information. I really liked that analogy because it kind of describes a little bit better what is actually happening behind the scenes and why you might want to do something where it learns a whole new skill that it can't do. So well worth checking out the AI Show. Like I said, I'm all about signposts in this one. If you are interested in any other Azure AI services, it's a really neat way if videos are your thing, to just get a good grip on what these things do, why I might use them, why something's important in this space. Because I think we're moving so fast, it's sometimes quite difficult to grasp why we need another model, why we need a larger GPU for something, why, all those kinds of things. So answers that nicely. Final question is, can I trust my data is not being used to train foundational models? This one's a really interesting one. It's one that gets asked a lot the minute you kind of go, yeah, I'm bought in, like this is well exciting technology. You have to ask then the questions of, how can I make this real within inside a business? And this is getting low, please charge when possible. It's nicely gonna always. And so one of the first things I just want to show is our classic Azure AI is built on trust slide. If you are working on anything around generative AI solutions, co-pilots on Azure, remember Microsoft.com/Trust Center. You've probably had to use this before for where does your data reside, how is it encrypted at rest and in transit, and get all of those documents that very clearly call out exactly how we do things with our services. So I just wanted to flash this up and obviously call out your data is your data. Your data is not used to train foundational models, and your data is protected by compliance and security controls. So with it being in Azure, it resides inside Azure and has the same policies around it. Then I often hear this question, but can I really trust that my data is not being used by foundational models? And it's kind of that hint to that answer wasn't quite enough maybe. And so what I wanted to point you to specifically is actually in the documentation, we often call out then in a little bit more detail that's probably, in my mind, was a little bit more developer friendly than maybe some of the more like privacy documentation and all of that kind of stuff. It kind of calls out within the language that we use in this space things like your prompts, which are inputs, and your completions, and your embeddings, and your training data, and calls out explicitly are not used for this, and not used for this, or this is what happens, sort of thing. I like these. To have a good read of them when you get into the documentation and you're trying to do these bits and bobs. But also, what I wanted to call out was that we have these things now called transparency notes. So as I've heard from Microsoft, responsible AI is a key pillar of what we do. We want to both build responsible AI solutions ourselves, share best practices of how we are doing it inside Microsoft, and encourage and help customers to build their own responsible AI and use these services responsibly. Think about how they're going to be used and who they're going to be used by. It's an area that's always under development, whether that's policy development, research development, or tooling development in responsible AI. But one of the key things is with any service that we do, so this one specifically was for some of the evaluations and like Azure content safety and stuff like that, you'll find something called a transparency note, and below it, it'll explain as well things like, what is this product designed to do? And what is it not very good at as well? We are terrible in technology sometimes for trying to shoehorn a technology that's not meant to be there to do things that we want it to do because we probably know a bit about the technology. And so we're like, oh, well, we can do this workaround. With AI, it never feels like that's a good idea. You should always explicitly use it for what it's good at, and potentially when it's not good at something, understand that and understand whether that would affect the outcome that you're using it for. And so anything where we provide AI services, we provide this kind of information, which is, is always interesting to know because it's quite a different stance from what's happened in the past. We provide a technology, but we don't always say, maybe on an open source, it's like, here's all the issues sort of thing. But actually to say, this is what it's good at the moment, and this is what it's not good at. So yeah, an interesting new thing just to be aware of that's available. Now with that, I'm keeping you from your commute home. So I just wanted to leave you with some things, as I said. There is so much going on in this generative AI space. It is moving at the speed of light, both research into product, but also how products are being used and put into production. Yeah, is there a question?
Sorry, I've just got one quick question with regards to the foundational models.
Yeah.
So OpenAI has got foundational models like DALL-E and GPT that's also in Azure OpenAI.
Yeah.
But how often do Microsoft update? For example, you've got Sora as well in OpenAI, which generates video from prompts, which I don't think is in AI Studio yet. But how is Microsoft adopting these sort of from OpenAI, or do you have your own ones, your open foundational modules?
Yeah. Bit of both. The answer is a bit of both. So we have a very strong partnership with OpenAI, and that's why we have that Azure OpenAI service specifically, so fully managed inside that enterprise environment. And what you'll often find is the partnership means that those technologies tend to come into Microsoft quite quickly. With Azure OpenAI service, there is a form that you have to fill in, and you have to select exactly what types of foundational models you're interested in using. That relates to partly responsible AI, partly how we do things with, all sorts of things behind the scenes with Azure. But one of them is responsible AI. Like, for example, we know that there are issues, right, that could come out with how these different foundational models get used. Sora, Whisper. Like, one of the interesting things is how do we, one of the ones around the speech avatars is a great example. You have to tick a box that says you have the permission of the person whose voice this is to use this voice. And obviously if you don't, you won't be able to use the service, sort of thing. So there is lots of pieces in there that we're trying to do to manage kind of how these things are being used, because they are very powerful and very fresh technologies. Do we have our own? Yeah, there is like loads of large language models, and the Azure AI Studio is definitely the place to go and check out what we've got there. Models as a Service, specifically it's called, or the model catalog. And in there you could find models from some of the providers you might have heard of, so Hugging Face, Mistral, Meta with their Llama models, etc. The idea being there that I feel like with everything on Azure, partnerships are key. We want Azure to be the best place to run workloads, like end of in some senses, and it's the same thing here. We want to make sure that you have all of the things available for you to be able to run great AI solutions on Azure, and one of the things that people are looking for is the ability to pick and choose which models they want to do. a lot of these models are designed for different things as well. Some of them are small language models, which is a slightly different way of looking at, what is it specifically I want to do with this this model, rather than large language models, which have like a big capacity to understand different things as well. Some of them are more latency efficient, some of them are more efficient at retrieval, stuff like that. They're all designed in slightly different ways, trying to achieve different things. So yeah, there's definitely the ability to choose OpenAI stuff, and we have a amazing partnership there. But then on the other side, we've got this model catalog where you can go and take a look. There's open source models in there as well. You might be in a part of the market that is keen to use open source over proprietary, and that's an option for you as well. It's a great question though around when and how quickly they sort of land in there.
Amy, there is one other question from the chat here, which was, what is the best resource to learn about AI and Azure in general? Where can you point us to?
A huge one, yeah.
You're going to have a slide for this.
Of course I've got a slide on it. So I've got a couple of different things for you here. This is the one to take a picture of if you're going to take a picture of anything. So first off at the top, we have this amazing Discord channel that's around the Azure AI community, and we're really excited to have it kind of growing. We've been promoting it quite a lot. This is a place that if you are building with Azure AI, come see the other people who are building and what questions they're asking. And we have obviously ourselves as cloud advocates, but we also have engineers in there, etc., that are coming. They're doing community roundtables. There's a recent thing we've added from different product teams, and it's just giving you that knowledge, like, okay, what's happening in this space? And we know communities are great for sharing knowledge. I've certainly learned a lot today, for example. Next one is the global AI community. So this is a third-party community. This is not owned by Microsoft. We sponsor it though. It's something that we really believe is incredibly valuable. And the global AI community, go join it. They have local events. We have a lot of London global AI community events. We also have things that happen globally as well as part of that. And it's just an easy way to be able to connect with other people who are learning about AI in the same space. And as I said, it's not just Microsoft. You'll learn about all sorts of other different things as well that relate to AI outside of Azure and Microsoft. And it's always good to keep your attention on kind of what's happening there. Next one is, if you're building, we all know samples is the easiest way to get started. A blank template is difficult, a sample is easier to start to understand, and we have some amazing samples available for you on GitHub to just get you started on what's possible. And then, as I said, the AI show is our place where we talk about everything Azure AI with those product groups who build it, and it's a really nice sort of pretty chill sort of interview style show with demos, but they're quick episodes that you can kind of consume and learn a lot about. And then with that, I don't know if you know about it, Microsoft Build is coming up. This is one of our flagship developer events. It's both in person, but there is stuff available online as well for you. And it's May 21st to the 23rd. If you go to build.microsoft.com, you can go ahead and register. There will obviously be stuff from all sort of different parts of the business, whether you're interested in GitHub or DevTools or AI or Azure or all what it's like. All of them will be there, and they'll all be obviously talking about some of the latest and greatest that we are developing as of right now. So yeah, do get signed up. It's coming up soon. But with that, a lot of information. Keep track of these links. These are the best way to keep learning in this space, and it's been an absolute pleasure. Thank you so much.
Lovely. I'll jump up. We'll jump up as well. Why not? Thank you, Amy. Thank you so much. That was incredibly insightful, really valuable, I think. I'll put a frame here, and people can see you as well. That's the end of today. Global Azure London 2024 has come to an end.
Yes.
Over 7 or nearly 7 hours of excellent talks. We've been going since just after 10 o'clock this morning. Thank you everybody here for coming. Particular big thank you to all of the speakers. We had 11 fantastic speakers today, so let's give them another round of applause. Many people speakers and attendees have travelled far and wide. We've had people coming from, Birmingham, from Southampton, all over the UK. People attending here today from Paris, from Spain, from all over, and online as well. We've had India joining, we've had Denmark, we've had Netherlands, all over Europe as well. So that's really awesome. I wanted to say a massive thank you to the Reactor team, and particularly Rav. They put on the wonderful lunch and the and made sure that the venue was all geared up for us. So Rav's just walked in. We can give Rav a round of applause. No, I'm sure I had something else to say. No, if you're watching online, make sure you leave a nice like on the live stream. That would be amazing. The talks are all recorded, so if you want to go watch anything back you've seen today, you can. We'll put some timestamps, etc., on those as well after that. And
I think thank you to the wonderful audience, because we've had great audience interaction as well with all the speakers and in conversations as well. So it was great to have you all here.
Yeah, let us know if we could improve, what we could change for next time. But thank you very much for coming, and hopefully we'll see you, 2025.
Yeah.
Thank you so much, Amy.